All right, welcome everybody to the spring showcase. Although, from what I understand, with confusing weather, not everybody's feeling the spring. We're going to get started in just a minute. We're going to start with just a brief presentation about why we are all gathered here today. And then we're going to launch into the presentations pretty quickly. Our tradition here is to give very short introductions so that we don't get stuck in everybody's honor, but rather get right into the deep the business aspects and the technological aspects of the companies presenting. We have quite a few panelists with us here today. The panelists are split into the different sessions, but if you belong to a separate session, feel free to chime in. You're here, that's what matters, and you have something to say. The company pitching probably needs to hear it. So we're going to get started just a second. Yuval, do you want to put up the slides? All right, so as I mentioned, welcome everybody to the Spring Showcase. The Showcase is now a monthly event starting at this month, where we're going to be having these events based on different industry themes. Today's theme starts with the open topic as our tradition, and then we're going to be moving into the topic of this month's Showcase, which is artificial intelligence, machine learning, big data, and cyber. Next slide. Just make sure you've all muted yourselves. Our mission is very, very simple to understand, complex to execute. Our goal is to help advance small businesses, the innovators of deep tech, deep technology, together with the stakeholders, the investors, the corporates, the federal, the city, the state agencies. In order to accomplish this, we do two primary activities, but we'll get into that in just a moment. Our community is a business community for deep technology. And it's split into two types of members: startups on the one hand, the innovators, and stakeholders on the other hand, those that enable for deep tech to exist. Why deep tech? It's a good question. Why are we so focused on deep tech? Deep technology is exciting for a myriad of reasons, but first and foremost, it helps us solve the challenges of today that have yet to be solved. And also, with the help of deep technology, hopefully, we'll be able to address tomorrow's challenges. Why the Showcase? Well, what we're doing in the Showcase is we're enabling two things to happen. One, discovery on one hand, and the other hand, exposure. And both are important. We have two sides of the body, one hand and the other hand, and they don't always meet. There's great technology out there. It has use cases all over the place for the public sector and private sector. However, it's not always so simple to find it. The gate theory is pretty simple. Gate theory in physiological pain is that if you block the stimulus of pain, then with another feeling, then what happens is that the feeling of pain gets blocked. But this also can apply to what's going on here with the stakeholders. Stakeholders are inundated with technology companies that want funding, they want pilot contracts, or whatever game they're looking for. And as a result, the good, the interesting, the deep technology companies that could make a real impact can't actually get in. That means we have another issue, is because often the innovators themselves, they don't have the greatest design on their slides, or they don't have the greatest look, but the technology is fantastic. The business could even be fantastic, but maybe they're lacking on the marketing side. And so the great technology gets hidden. And the reality is, in order for deep tech to come into existence and make an impact on our lives and in the market, we need partners in order for that to happen. Our startups participating in the Deep Tech Showcase are three criteria they meet, which is namely they're developing deep tech, as the name suggests. They're developing dual use technology, which means that they have use in the public as well as in the private sector, and that they've won some sort of government fund for their R&D, or also if they've had contracts in the past. Stakeholder is defined very clearly by somebody from the public sector. It could be federal, state, city, major corporations, and their tech scouts looking for innovative technology to assist them with their projects, and of course, investors. We help companies through 3 stages. The first is getting ready for meeting the stakeholders. The second is which is guided introductions. You all go to the next slide. Guided introduction, which is very simple. You don't want to necessarily talk to every single company because not every company is going to be relevant towards your aims. And so what we do is we do company profile shares based on the stakeholders' interest. If there is an interest, then introduction follows. And the third is showcases like the event we have today. Talk about our events for just a moment. We run monthly events at this point. This is where we're officially kicking off into a monthly event. We've had 4 events so far. 2 were investor focused, and this is the second one, which includes the full gamut of stakeholders, the public sector stakeholders, federal, city, and state, as well as investors and major corporations. This is our schedule. So we had on January 28th was our first events. March 3rd and March 18th were VC pitch events. And from here on out, it is the full gamut, starting with today's events, AI, machine learning, big data, and cyber. Next showcase happening on May 20th, so just about a month from today, is focused on Industry 4.0. We're gonna have 3 sessions, open topic, Smart Factory, which is what we're entitling the brain, and Advanced Manufacturing, which is the broad. Today's panelists. Okay, so we're gonna have 3 sessions today. There are more than just the panelists that appear here on this slide. And feel free, all panelists, this is my plea to you, is that when you have something of value to say, please chime in, even if you belong to a separate panel. But the primary panelists, as you can see today, from a really wide spectrum. The panelists themselves will introduce themselves as they pipe in, but we're really blessed to have a great group of professionals and expertise that goes beyond what we could fathom on a great platform like this. Today's pitching companies, starting with the general tech, and we're gonna go back to this when each session starts, but we're just about to launch into the general tech pitch or the open tech pitch. We have OptiPulse, Elementum 3D, Trax NA, Molecular Rebar Design, Aquavio, and B612. Afterwards, we're gonna have our second session. We have a fantastic panel for the AI, machine learning, and big data. And moving on, the companies pitching. We're gonna be speaking to these 6 companies, which we'll introduce right before the next event, for the next session. And then for the cyber session, for those strong that stay, you make it all the way through the 3rd session, we're gonna have a great panel as well as the following companies are going to be pitching as well. So without further ado, I believe we're about ready to get started. If you have any questions, you can contact Asher at deeptechshowcase.com. You can connect me, Josh, at deeptechshowcase.com, and I'm pretty sure you all have Yuval's email, Yuval at deeptechshowcase.com, or see more about what we're doing on our website. So let's get started. I believe the first pitching company today is OptiPulse. We have John Joseph, who's the CEO of OptiPulse. John, feel free to get started, unmute your mic, and we're excited to hear about your technology.
Hi, okay, so let's see, we're OptiPulse. What is 6G? I'm going to start out with that question. It's a wireless technology that's faster than 5G, uses less energy, costs less, and is easier to deploy. OptiPulse is announcing world's first 6G emitters for sale to product developers. We're seeking $8 million next. So, hi, I'm John Joseph. I'm the CEO, founder, and I lead an elite team of photonics professionals. We all worked together many years ago at the national labs, and we're known for optimizing the first laser transceivers that enabled fiber optic communications. Next. What we've discovered is a new type of photonic source that has enough power to give us wireless connections at distance. What this will really mean in the future is a better communications model. We can do 25 gigabit per second backhaul, low energy use, low cost, fast deployment, and this will all bring about a digital equality. Next, please. What we have is 8 patents issued on a new type of photonics light source. And as you can see on the picture with the finger that has a tiny chip on it, that chip has 37 lasers on it. And there's the microscope image of it next to it. It has lasers on one side and micro optics on the back. The combination yields a very unusual type of light source. Basically, as you see here in the left part of the screen, if you image on the surface of the chip, you can see, in this case, it's 19 lasers. But if you image back through the chip in the focal plane, you will see back here at about a millimeter and a half, you have a very uniform power source. And so this is the power intensity, which is like a top hat profile. And that means we can project that into the far field at gigabits per second. These chips have been tested at 25 gigabits per second with simple on-off keying. What can you do with these things? Well, since the micro optics allow us to sum the beams together, we can also move them in the X and Y and allow us to put multiple chips on a single beam. Now that allows us to multiplex in wavelength and pulse amplitude multiplexing, pushing speeds, bandwidths up to hundreds of gigabits per second. Also, if you can array these and you move those micro optics around, you can actually use non-mechanical beam steering, which enables, like, imagine a projector in the far field and a drone coming through this, and you're able to sense and communicate with a moving object. Next, please. So what does this allow you to do? There's an amazing amount of use cases here. Just to give you some examples, backhaul, front haul for 5G and of course 6G, infrastructure, different speeds, but let's just take the automobile vehicle to vehicle communications market is projected to be 139 billion in 2017. Next, please. So we are delivering the modules for the 6G emitters, detectors, evaluation boards, and evaluation links in Q4 of this year. We'll be doing mesh networks in 2022. Next, please. What can you do with this chip? Well, you put it in our prototype 3, you put it in a system. We've had 10 gigabit per second building to building communications, and that we have taken that was a mechanical system. Now we have a digital system, which is self-aligning, and we'll be testing this in September of this year and in our alpha product, and have the beta out by Q1 next year, which we will be selling to developers for their systems. Next, please. What problems does this solve? Well, if you can imagine a fiber optic installer that has to come to a river, what do? We've heard from our customers. We were in the NSF I-Core training and had to talk with 100 customers. One of them told us $360,000 in 3 months to get across a one foot river. And that is because you can't go across bridges. The Army Corps of Engineers doesn't allow that to happen, any kind of structural changes. There's all kinds of use cases going across highways, bridges, and cities, train tracks in a mesh network with redundant links. But the very interesting thing is what this will really lead to is a better way to connect rural cities next, which enables space links that can be transported over to a rural community way out of the way that with a fiber optic speed. Next.
30-second warning.
Okay, so thank you. Lots of traction here. Can't go into all of it, but I'll sum it up. With our Department of Defense contract, we got an overachievement status in phase 1, and we are in phase 2 on schedule and on budget. Next. So we're seeking $8 million. Here's the details on that. And basically it's a 1.5 years of chip development, forecasting, deliveries, and engineering applications, sales and marketing, and IP development. Next. That will give us 2 years of basically in 2 years we'll be cash positive, and we are leading the way to 6G development. We're looking for investors that are not afraid to change a lot of problems that we have today in communications. Thank you.
Thank you, John. So, John, I know you've had quite a lot of traction so far within the government, and you've seen a lot of traction also through the showcase, both in government and also in corporations. So we're opening up the floor at this point. We ran through it real quickly. I'm just going to recall everybody the panelists for this session. We have Ryan Hatcher from Lockheed, Jeff Everett from Moog, Alex Ferber from Green Egg Ventures, Destry Grogan from Army Futures Command, Sodi Yoshi from Mitsubishi Heavy Industries, Alan Yu from Space Capital, Tim Crane from Army Futures Command, Whitney Tallarico from Naval X, Charles Quofer from Siemens Digital Industry Software, Jacob Hahn from Deloitte Consulting, Jen Noborikawa from City of New York, and Joshua Davis-Court from the United States Space Force. So open up the panel, as I said before, additional panelists, if you already on for your later session, feel free to jump in if you have something to say to John and OptiPulse.
Anybody got any questions?
Can I just speak up?
Yeah, go ahead, Ryan.
Yeah, sorry. Hey, great presentation. Thank you for that. Curious about the impact in your link budget with rain or smoke or fog or dust. Do you have any estimates on that or any data?
Yeah, we've so what we've do on the chip is we expand that beam out through the into the or through the micro optics into the macro optic, and that beam expansion allows us to get through a lot of the weather issues like snow or rain, where small objects, of course, if you're sending data from one link to another, you only have a few microseconds for the data to get across. So typically there's plenty of light that you can collect on the other side that gives you the data you need. Now, of course, it's all based on power, just like RF. It's based on power. Is how much power are you able to get? Well, that's what's so cool about our technology is that 105 VCSELs is just as fast as 1 VCSEL on the same chip. And that allows us to get amazing amounts of power, turn the power up when it's necessary. There is going to be an atmospheric point at which you can't go any farther, but we definitely have the way to beam steer and get higher power. Thank you. Thanks, Ryan.
Can I ask a quick question, if it's okay with everybody?
Please.
Actually, John, great presentation. Actually, I have a particular interest in your field. That's why I wanted to kind of speak up. I know 6G has a lot of great potential, as we all know, but there's always this issue with the security, right? The security and privacy issues, right?
Yes.
Especially like this 6G is basically it's greatly be used in connected robotics or autonomous systems, right? Typically rely on like AI and VLC technologies. So can you comment on that? How are you going to overcome? What's your plan for that? Or please.
Sure.
And also one more question here. Have you attended the first, I believe, first 6G conference was in Finland? Have you attended that 2019?
No, we did not.
Did not? Okay.
No, but thank you for that question. Very good question. Of course, 5G is based on a cell technology, which is high frequency RF. But the problem with 5G basically is that once you get to those kinds of frequencies, it's line of sight. Well, so is light, but we can do things that the RF can't do, like go through a window with their high frequencies that allow a gigabit per second or a couple of gigabits per second. We can put a light beam through a window at 25 gigabits per second. So what we're trying to do is show a new model in 6G that allows like a 4G on steroids, which gives you excellent cell phone connectivity and very high bandwidth. The real issue with our bandwidth is basically the backhaul that supplies the RR units for cell phone service. And so we're able to get a really high backhaul in a mesh network with a type of smart pole that we can go into later. But thank you for that question. And the security part, optics, of course, we're at the NIR or near infrared wavelengths, so much more secure than the radio wavelengths that is 5G right now. Thank you.
Great. Maybe we can perhaps chat afterwards, please. Thank you. I'll put my email in the chat room. Thank you.
John, two things. One, thank you for working on a tech that's actually not RF, because I've been hearing a lot of people concerned about 5G, genetics and health and safety issues and concerns and things like that. So I think you might have solved that problem. And that's first question. Second question, have you worked with Thales in France? They're have 80,000 employees in the security space, so they may be able to help you with anything you need in terms of securing or government or military grade security.
Well, thank you very much. Yes, I do know Thales, and I did meet with them early on when we were forming our company, but we didn't have systems ready. We just had theory. So we've done quite a bit since then. We've been open for 6 years now. And we'd certainly like to meet with you and talk about that, because they actually have the systems that for driving high current drivers that we really could use in our modules for space and telecommunications. Thank you very much for that question.
Reach out to me when you're done, because I have high level contacts at Thales who are doing the whole digital. They're changing everything from hardware to the cloud. So the whole data transformation architect I'm working with.
Thank you very much, David. I will certainly do that.
Sure.
Background, David's from Proto Ventures. He's mentioned contact with Thales, but David's from Proto Ventures. Wonderful. Moving right on, we're going to jump into SpaceMap. Presenting SpaceMap, we have Tanika Remy, president of V612.
Thank you. I'm delighted to be here today. Did you know everything in space is location-based? Our premise is that there is no robust space-based economy in the future without location-based services. We're building a SaaS business to enable the future deep space market. Next slide, please. Why are maps important? What makes a map valuable is that to develop a new frontier, it always requires a map. Whoever holds the map to a new frontier holds an extremely critical key to the future. From the great age of exploration, the major powers sent explorers around the globe to map things. The very first international company, the Dutch East India Company, which was powerful for more than 200 years, held that power because they had superior maps. And in the 1990s, Craig Ventnor knew that to fully take advantage of the benefits of the new field of genomics, it was necessary to map the human genome. Next slide, please. Fast forward to today, 99% of our solar system is not mapped. We believe anyone who has the space map will have a profound advantage. So where does the space map all begin? In space, everything is in motion. In order to create this map, you need to start with trajectory software. Does this software exist today? Yes, but it's slow, expensive, and complicated to install and run. We aim to make these kinds of calculations in near real time on a SaaS platform. Next slide, please. Let me ask you this question. How much would it cost to buy Google Maps today? Did the rest of the investors and the rest of us imagine Zillow, Uber, or Yelp just a mere 16 years ago? Google enabled them because Google had a map for others to build upon. Google Maps drives the vast majority of the market today. To enter the location-based space market, you'll need a map. Space is all about trajectories, where you are and where you're going. And we believe the longer-term opportunity for us will be a merger or acquisition. What we're building is a moonshot that goes far beyond the moon. Engineering and business milestones over the next 5 years will establish our long-term leadership and cement our first mover advantage. Our map, next slide, please. Our map will enable the future economic development of space beyond the crowded field of low Earth orbit, where the majority of all the satellites, instruments, and space junk reside today. The deep space market will be enabled by access to a dynamic, four-dimensional, time being the fourth dimension, map of space. Our map will open up possibilities beyond Earth. Next slide, please. Our near-term customers are companies building, flying, and operating space missions. These satellite builders and commercial aerospace companies have navigation teams. The team is typically a group of PhDs. They buy expensive software or write their own software or use open source software. Then they customize it and build it and rebuild it and create algorithms over and over. Essentially, it's homegrown, inefficient, expensive, and slow. Our software delivers trajectories and mission plans in minutes, not months, and without the team of PhDs. Our near-term market is the growing commercial missions and perhaps the government, missions that are going to the moon and beyond, to deep space. Similar to the recent development of launch services by entrepreneurs, which dramatically reduce launch costs, our software will reduce costs and navigational planning time. In the near term, we're confident in achieving a positive cash flow. In the medium to long term, we plan to enable a new era of deep space mobility. Next slide, please. Now, you might perceive some of these companies as our competition. They focus on providing services just above the atmosphere. They operate man-made objects that circulate around our home planet. These companies track satellites and space junk and deliver Earth-based mapping, navigation, and communication services. Our customers are going beyond Earth. Next slide, please. Now, in order to build the space map, you need experts in astrodynamics. That's the study of things moving in space, and cloud developers, and experts in satellite and space mission operations. If you don't have all three, you cannot build this. Dr. Ed Lu leads our product team and is a former NASA astronaut with 30 years of experience, including being an early Google Map leader, as well as co-founder of Leo Labs. Carice and Kathleen were recruited from Google and Lockheed, and Hank is the CTO at Applied Defense. John Allen and other members of our team have decades of space experience, and our work is supported by partnerships and funding from Google, AGI, DARPA, and others. Next slide, please.
30-second warning.
Yep. So what's our technology? It's a cloud-based platform that calculates where things are and where they're going in space. And we're building it on Google and in the future other platforms. And we're building it at scale. Next slide, please. We believe that space is the next great frontier, and whoever controls the space map, as in all other frontiers, is going to have a tremendous advantage. Next slide, please. We're seeking patient funders and partners who share our long-term vision for the space economy. Won't you join us? Thank you.
Open up the floor for questions for Danica Reming from B612 or Developing Space Map.
Hi, great presentation. This is Charles Krufer from Siemens Industry Software. Danica, I just saw quickly the logo. I was going to ask a question about AGI because I'm familiar with AGI, and I saw the logo on one of your last slides. I was curious because we see that as a good potential as we provide software for simulating all those objects, satellites, aircraft, and so on. Being able to couple that with mission planning software would be great. We were initially working with AGI, but now they've been acquired by Ansys. So just curious how you position compared to AGI.
So AGI has been quite instrumental in the development of our software. They've been a really great partner. They're very focused on the low Earth market, and our market is, I said in the presentation, is really beyond low Earth orbit. And we're trying to build a SaaS business, and as you know, AGI, although they have a small SaaS product, the vast majority of their income is from a desktop-based licensing product that has a price point of an annual seat license of $250,000 a year. So they are very supportive of what we're doing because we're going beyond low Earth orbit. And they're looking at us, obviously as an opportunity to understand how you might be able to provide the SaaS services in a different way than they're currently doing in their current product suite. And John Carrico was a lead developer on something that's called the Satellite Toolkit. And John Hank also worked at AGI. So, we're really leveraging a lot of the work that was done by that key leader in the field, but we're trying to apply it both to a different market and to a different platform suite. Does that help?
Yes, it does, absolutely. And so you partly answered my second question, which was about if your tool would also be applicable for low Earth orbit. And I guess I wasn't clear if it
Yeah,
is not. Or it could be.
Yeah, I mean, the kind of the fundamental parts of it, if I boil it down to just the smallest part, when you're in Leo, you have Earth at the center of your model, and you have all the force factors that have to do with being in low Earth orbit. Because we're looking at a market that is the deep space market. The sun is at the center of our model, and we have to use force models from, just dozens and dozens, hundreds and hundreds of different kinds of force factors. And so our computational challenge is a different one than the low Earth market. So while we could, we're not going to, in particular because that's AGI's market and we don't want to be in it.
Yeah, got you. Okay, thank you.
Wonderful. Okay, we're gonna move on already to the next presentation. Thank you. That was Danica Remy from B612 and their SpaceMap development. Anybody's looking for forward thinking and opening up both exploration and also the new market in space, please contact Danica. Danica, reminder, anybody that has questions, you can answer questions within the chat, open it up as well as for attendees. Okay, next up we have Caleb Holt. From Trax NA, and also joined by Hunter Woodruff.
I'm sorry, I was muted. Can everybody hear me now?
Loud and clear.
Yes.
Okay. My name's Hunter Woodruff. I am the business development manager here for Trax North America. We manufacture and distribute unmanned vehicles. Next slide, please. What we have is the multi-purpose expeditionary platform. We call it the MPEP. The MPEP is a remote control materials handler that is diesel powered, has auxiliary hydraulics. This machine can lift its body weight almost. So our machine weighs 4,500 pounds and it can lift 4,000 pounds. It can also carry 10,000 pounds on top of it. Our biggest thing is our overview. We have won an SBIR with the Air Force to make these machines autonomous, therefore removing any person that would be in danger while operating machinery. Let's see here. Next slide, please. Okay, our technology here, like we said, is the MPEP. That is a 36 horsepower diesel engine with an 8-hour runtime on 5 gallons of diesel, so it's very efficient. You can operate this machine anywhere within 1,000 feet with our wireless remote. Operational, it can take its full weight capacity, so 3,500 pounds. You can go up a 60% grade with it without it tipping over because of our load shifting abilities. That's our intellectual property, really, is we're able to change our center of gravity in 3 different ways to center our load and create a safe working platform. Multi-mission, multi-role, wireless control tracked platform. Okay, next slide, please. Okay, so currently the United States military and everybody in the equipment industry is used to using skid steers and machinery that you sit on. The biggest problem with that is that there's around 13,000 injuries a year and 1,200 deaths a year from people being crushed or rolling these machines over. With taking those machines and their capabilities and making them remote control, you can take away the risk of somebody being in that working environment. Next slide, please. Okay, advancing the MPEP. We're currently asking for $500,000 in investment to advance manufacturing. We are trying to bring the manufacturing back to the United States. Like I said, we're working with the Air Force to do the autonomous aspect of the machine. Short-term goals is to validate our technology through the Air Force Phase 1 SBIR that I had mentioned, and transition into Phase 2 by the end of the year. Our target market is military and commercial construction, transportation, and logistics market segments, and transition manufacturing College Station, like I said. Next slide, please. Okay, the commercialization potential. We recorded $455,000 in revenue from 2018 to 2020. Under contract are 4 of our machines with the DOT Department of Georgia. And we also received $350,000 investment from Switch Track Ventures. What we've done as far as demonstrations, we were able to do a ROMS demonstration, so Rapid Obstacle Marking System for the United States Army. We've also done hurricane cleanup. We've done the snow removal. We've actually been asked by the United States Marine Corps to create an austere package for them. So they were able to fit our machine into a Connex box along with 4 of its attachments and be able to sling load or airdrop this machine and its attachments anywhere in the world. Non-DoD demonstrations, like I said, we did Denver International Airport. These machines were actually designed to load and unload aircraft. So they will fit under the rotors of helicopters and under the wings of planes. So therefore you're able to come in closer to the aircraft and load and unload things that you typically would not be able to in the past. Next slide, please.
30-second warning.
Okay, I'm going to give you a rundown of our team right here. Our parent company is Axelbox Innovations. Caleb Holt is our founder and CEO. He has been in the defense industry and worked for Texas Engineering Extension Service for 11 years. The biggest reason he started our company is there was great technology coming across his desk there at Teach that he was not able to move forward with due to bureaucracy. So he started this company to be able to take technology that saves lives, that gets people out of danger and advances our life. And he's able to put them in a market without the bureaucracy. Mickey Bird is our electrical engineer. We call him the wizard. He can pretty much fix, change, and create almost anything with electronics. He is one of a kind. Madison Jones is our civil and design engineer. He has been working with all of our CAD drawings and doing all of those things for our new machine. So when we move manufacturing back to College Station, we will be able to go full steam ahead with all of our designs. And like I said, my name's Hunter Woodruff. I am the portfolio manager, and I work with these machines on a daily basis. If you guys have any questions, I'd be more than happy to answer them.
Say, Hunter, this is Dana Jensen. I'm from the Air Force's Office of Commercial and Economic Analysis. We work very closely with AFWorks, evaluating SBIR proposals and works with Agility Prime and several other things they're doing to push innovation in the Air Force. And certainly there's a lot of talk internally about the flight line of the future, right? And the idea that we want to automate or make autonomous ground handling. And so I wonder, your current prototype is remote controlled. Can you kind of share what you think your roadmap looks like in terms of getting the right sensors on board and getting the right systems in place for autonomous operation?
Yep. So our roadmap right now, we're at the starting line, to be honest. So we just won the phase 1 SBIR with the Air Force. So they're giving us $50,000 to come up on paper with how we would make this machine autonomous. So we will start that. We will start that journey within the next couple of weeks, and I'd be better able to answer that. To be honest, we don't know how we're going to make it autonomous. I know it can be done, but we're just getting into the research phase of that.
And I'd like to add, this is Colby Humphrey. I'm with the team as well, and we are currently working with a group called Viking UAS, which is they do a lot of autonomous drones and other unmanned systems up in New Hampshire, and they're a critical partner for us on this project. And we're also working with multiple professors out of Texas A&M University based off our location in College Station. So we're going to really be leaning into their expertise on that particular front.
Hey, Hunter, this is Jeff Eric from Moog. I actually work on the drone side of the house, but we're a big company, and we actually have an internal area focused on autonomous and electrified heavy equipment, right? So we're not building the vehicle, we're missionizing the thing. So I think we should probably have a conversation. And to Dana's point, we actually have a system that's in use for FOD detection on the airfield. And the next phase of that system, it's installed at Yuma and a few other places like Heathrow. But the next phase of that is the action part of it, right? You need to send a vehicle out to go rather than doing the walk down the airfield to go take care of it. But again, we're not making the vehicle, but we're helping to missionize it. So we do work with autonomy, that kind of stuff as well, both on the aircraft side and the ground vehicle side. So why don't you reach out to me, because I think we could have a talk and we might be able to have further discussion. It might be worth both of our time.
Absolutely.
My name's
Jeff-
Josh Daviscourt. Believe it or not, I'm active duty in spite of the haircut. So I'm in the Space Force now, but I got my start on the flight line as a pilot. And I was just curious, do you have an end user already lined up to take this into a phase 2? Because if not, I know a few people over at Phoenix Spark and then Aloha Spark. They're really sharp engineers. I don't know the answers, but I'm sure they'd love to be part of that journey.
Okay.
We would love, we would love to talk to them. If anyone that you have that you could put us in contact with, that would be great. We've had preliminary discussions with some folks here in Texas with the Texas Air National Guard, but we'd definitely love to talk to whoever you know.
Yeah, I'm a spacecraft guy now, but I did a few projects with those two groups, and I think they'd be a good fit for you.
Great. Yeah, that'd be great. Thank you.
Wonderful. Amazing. Another great company from Axel, incredible technology. And if you ever want to be in contact with the team, Colby and Hunter and the team, please do so. And again, remind you to use the chat. Next up is Elementum 3D. We have Jacob Nocturlane, president and founder of Elementum 3D.
Yeah, thank you. Okay, so Elementum 3D. We develop new materials for additive manufacturing, primarily in the metals additive manufacturing space. We work in metals and ceramic composites and develop new products and materials based off of that. Next slide, please. So the current problem with a lot of additive manufacturing is you're limited to the materials that you can choose because it is typically a welding process. And a lot of those materials you can't produce. They have poor properties, and you can't make the same component that you could, say, with CNC machining. Next slide, please. Our materials and the development of our materials allow the use of all sorts of materials, whether those are traditional materials or new materials like metal matrix composites, high-tech materials that we couldn't produce using CNC that are now possible because we have all of the design freedom and now the materials freedom, which isn't typically thought of in additive, that didn't exist before. So we can do things and design things with materials that were not possible to make previously. Next slide, please. So we've been in business for about 6.5 years now. We've developed a number of different materials for all sorts of applications, whether that's rocket engines, in which we have a small manufacturing setup to help transition and develop new rockets for space flight. Then we have a number of different technologies and developments that we've been working on for all sorts of other fields as well, whether that's lightweighting for aerospace design. Typically it's consolidation of parts for all sorts of applications, whether that's just for lightweighting or actually more popularly for reducing the supply chain and improving the security of that supply chain as well. So there's a number of different fields that we've been focusing on, both in space, aerospace, high-end automotive manufacturing, cooling for, say, data farms and servers. And then recently there's been quite a bit of interest in hydrogen extraction for fueling as well. So a number of different fields where we can apply all sorts of materials, from high-strength aluminums, ultra-high temperature nickel superalloys. Recently, NASA contracted us to produce and develop their systems and settings for GR-COP 42 and a few other materials as well. Next slide, please. So our business model is that we develop materials and we sell those materials to people who own these metal 3D printers. We develop the settings and the post-processing for those printers to be used with our materials. So OEMs like Lockheed Martin, Moog, those sorts of companies could purchase our materials and print their components using those high-strength materials. From there, we also do consulting services and help those companies take it from that initial concept to an actual producible part that can compete and even in most cases beat that component by 60, 70% performance improvements, which we found you have to be at that 60, 70% improvement for someone to adopt this new type of manufacturing technology. And further than that, we do a lot of initial run manufacturing as well. So we will help develop different products and develop the manufacturing line on our end, and then transfer that to the end use customer so that we can transfer our knowledge and help that customer set up the manufacturing. Next slide, please. So a number of our customers that we can talk about, most of our customers we can't talk about and we can't say their names, which makes that very difficult sell. But some of the customers that we have done business with and have posted publicly as what they're doing, it might be Ball Aerospace, Maston Space Systems, we've done quite a bit of work with, and then a number of the DoD contractors that are directly contracting with the Army, with the Air Force, and with the Navy, we've done quite a bit with as well. We've also been awarded about $5 million in contracts with NASA, the Air Force, and others over the past 5 years. Most recently, we were awarded a phase 1 SBIR with the Air Force to develop and further develop high stiffness aluminum materials for replacing all sorts of maybe caustic or materials like beryllium containing alloys, which can be really dangerous to people's health. So we've been working on those sorts of materials recently.
30-second warning.
Next slide, please. So our technology is really based around the development of those new materials, and our IP, which is based around what we call reactive additive manufacturing. And essentially, we're forming these materials and adjusting their microstructures based off of adding these reactive components to it, which are actually forming and reacting during the printing process in a very controlled way, so that we can develop and change the microstructure and strength and properties of those materials as we go. Next slide, please. And there's different advantages to that, and there's highlights here, but I think the biggest highlight on this slide is that we can print materials that you can't print otherwise. So by using this technology, we can print high strength aluminums, which traditionally you could not do, and others have not been able to figure out how to do. Next slide, please. We're looking to do a Series B raise. We've raised up to $10 million so far, and we're looking for a Series B coming up this summer to do an additional $20 million raise. And we're looking at very, very large revenue improvements. We're already profitable as of this year, which is exciting. We've tripled our revenue recently. So there's quite a bit of work being done there, including relatively large contracts that we slot in well as a subcontractor on. So that's the sort of work and that's what we're looking for from this sort of relationship. So next slide, please. And that's our team. So I don't think I have to go too far into that, but we do have a significant team of metallurgists on staff and people who know the other side of it as far as sales and accounting.
Thank you, Jacob. Open up the floor to questions for Jacob and Element 3D.
Hey, Jacob, this is Dana again. We've started to get the sense that metal additive manufacturing powders could be a potential bottleneck in the supply chain for advanced air mobility, right? For eVTOL vehicles as they come up and scale. Is your solution? I mean, if I'm a startup in AAM and I just invested a whole bunch of money in Velo 3D equipment or whatever, are you saying we can just basically drop your powders in and it won't take any tweaking in terms of the power sources or anything else with the existing commercial off-the-shelf equipment?
That's correct. The commercial off-the-shelf equipment is usable. As specifically with Velo, we haven't developed our settings for the Velo equipment in particular, but choose about any of the other ones we have. Velo is just a younger company. It would take us about 6 months and we could work directly with Benny from Velo, who we've met a number of times and talked about projects. So absolutely, that's something where we are taking our materials and dropping them directly into the printers out there. EOS is the most common and most familiar. I think it's about 60% of the metals market. We have a good relationship with them. Also with SLM 3D Systems, we're about 20 miles from. So yeah.
Are you reliant on imports for any of the specialized chemicals involved with this, or is it stuff that you can source pretty easily?
Specifically, we're sourcing it in the US because a lot of our customers require that.
Yeah. Okay, thank you.
Hey, Jacob, you had mentioned Moog in your pitch. I'm not an additive guy, but I know we do a lot of stuff. Are you engaged with Moog right now? If you're not, I can make a connection for you.
I don't need the connection, and
Okay,
I don't know how much I can say.
that's fine. It's in my group. I just yeah, that's fine.
Yeah.
No worries. I was just gonna help you out if you needed it.
Guys pretty well. We know those guys pretty well.
Jacob, are you doing anything with housing at all, with 3D printing of housing?
So we're not. We're focused mainly on the metals market, which doesn't go into, say, like concrete printing as much. But
Well, I meant for multi-story buildings, even commercial buildings, as far as if you can print out the infrastructure and redesign the way buildings are built, and they can go up a lot faster with a lot, just similar to an early presenter, without the dangerous heights and things that humans have to do skyscrapers and stuff. I should have said commercial. Yeah.
We are spinning out actually a wire division that will be going into wire feed additive manufacturing for doing things like building more structural components for larger pieces. So that is something that we're just starting into, and we're looking actually at an SBIR with the with NASA, looking at some structures there, but we haven't gotten into printing and construction yet.
Okay, thanks.
Okay, that was Elementum 3D. Any other questions? Feel free to connect to Jacob after. Next up, we have Aquavio, led by Roy Nelson and Alan Lemon, VP and team leader.
All right, this is Alan. Thank you all for having me. Let me tell you a little bit about Aquaveo. We're a small software company located in just south of Salt Lake City in Utah. Next slide. What we try to do is we make tools that enable better decision-making by making information from complex numerical models and spatial data easily accessible. Whether that be, in general, it's to take things that are being run by PhDs and maybe have difficulty communicating those and making them into easily understandable pictures. Next slide. Traction, this shows you over the years who we've worked with. We've been around for quite a while, actually. As a company, we've been around for a little less than 15 years, but as researchers and research lab, we've been around closer to 30. And these are some of the entities that we've worked with. Next slide. So our company was established in 2007. We've been able to average per year around 8,500 in contracts, mainly with Army Corps and Federal Highways as partners. We've got some established commercial products, software products, average sales around 2 million a year. We have a fairly large user base. We have about half of our sales come internationally. We have good established marketing channels, web presence, good SEO, and an international reseller network. Next slide. We provide some desktop solutions as well as some web solutions. And I'll explain those a little bit more. Next slide. So in terms of our desktop products, next slide, what I'd like to talk about is one of our partnerships with the Army Corps. So we have a package that we call the Surface Water Modeling System, and we've had an ongoing relationship with the Army Corps of Engineers with their Research and Development Center in Vicksburg, Mississippi. And that relationship has been around for about 20 years now, and it's been a very good synergistic relationship where we've worked with researchers at that center and helping develop tools to help them pre and post process complex numerical models that helps them get data into those models and then get data out of those models so that they can then get answers to decision makers. And that's been a really good relationship and an example of one of our successes. Next slide. On our web products, the top one there, we have a product called City Water that's a SaaS product. It came about because of a relationship with a civil engineering consulting firm that has many clients that are in the water distribution field. And they have a lot of municipalities that they work with. They approached us because they were concerned about the simplicity of workflows, both internally and then also delivering those results to their clients. And so they approached us about creating a web platform to be able to import these water distribution models that they have, and then also to be able to deliver results from those water distribution models to their clients without anybody having to install any software and just using a web browser. Next slide. So our competitive advantages, we're a small company, so we've got a nimble team. We don't deal with any bureaucracy. We're small enough we can adjust quickly. We like to fail on things quick and learn from it and be able to get good solutions out there fast. Our existing relationships show how we've been able to deliver to our customers, and our customers keep coming back. We've got good technical competence, some good organizational knowledge. We're very experienced with spatial data and computational models. And we also have a great customer service side of our business, where a lot of individuals in our space don't really like to do a lot of customer service. And so I think that's one of our other competitive advantages with customers of our products. Next slide. So what we'd like to do is we'd like to be able to expand our clients so that we are be able to help more government agencies have more success stories like we've had with the Army Corps, with federal highways, be able to extend that into other agencies and perhaps work with industry partners. As a small business, we can be subcontractors, or if they're small business set-asides, we'd like to be main contractors and then work with them. We're interested in getting more experience, just getting a larger clientele and being able to help more people with the kinds of services that we can provide. Next slide. Our team, so you can see me there. I'm Alan Lemon, president of Aquaveo. I've got a little over 20 years of experience in the field with software development and numerical modeling. Alan Zundel, with more than 35 years of experience. He handles our internal development. Nathan Swain, who's a little bit younger, but he's our web application development leader, and he handles our web services. So we'd really like to just expand and increase our opportunities. And I think that's it for me.
Wonderful. Open up the floor for questions for Alan Lemon, Aquaveo. One question coming through in the chat is whether or not Aquaveo also has an application to gases in addition to liquids.
So we are mostly doing incompressible fluids. There have been some work that we've done in the past where we have done multi-phase numerical models that apply either in fracking or other situations where you've got multi-phase. So the basics of our software and our expertise definitely applies to all those fields. We tend to not be the ones generating the numerical engines. We end up making the tools that make it easy to use those numerical engines. And so, we've got models that we support that are, research models, maybe one developer. We got stuff that comes from the USGS, from other government agencies, or even private developers. And our niche is that we make it easy for people to use and to get it on their desktop or in the web and actually have application out in the, by consulting firms and other government agencies.
Thank you. Thank you. Okay, so if there are no further questions, we're going to move on to our last pitch for the Open Tech, and then we're going to move straight into the AI, machine learning, and big data session. So we have Kurt Swager, CEO of Molecular Rebar Design.
Good afternoon. Thanks for the time and the help to put this on. So my background was with 36 years with Dow developing materials, and ended up being a vice president along with my partner, Clive Bosniak, had about 25 years as a material scientist. And what we did in our time there is we tremendously changed the world of polyethylene with some technology and expanded the boundaries of what you could do with it. And at the same time, we had our Central Research working away at nanomaterials to see if we could do that again, because one of the major problems with large volume materials is people have pretty much optimized it. How can you change the system so you can lower your cost? And so what we came up with, next slide, is after we spectacularly failed in Dow, we retired and decided to do it ourselves and formed Molecular Rebar. And what we did is we buy carbon nanotubes, which aren't nanotubes. They're really bundles of nanotubes, which are micron sized, and they don't really work very well for what we needed to do. So we learned how to make them into the individual tubes. So we really have a source of individual nanotubes about 800, 900 nanometers long and 14 nanometers in diameter. And we put them in materials wherever we can mix them. And for example, you can see those little strands on that lead paste. Those are actual individual tubes. And when you do that, you'd start totally changing the boundaries of materials. So let's take a couple examples. First being, if you turn the slide, is a popular one is lithium batteries. And these actually are designed more for electric vehicles. And what our capability is if we put our material in with silicon into a graphite anode, we can increase the energy density 20 to 40%. So same volume, 20 to 40% more energy, pretty straightforward how valuable that is. If we put our material on the cathode side, we can have it charged 4 or 5 times faster. So rather than charging your battery in an hour, 10, 12 minutes. And those were not possible until you had these individual tubes, which we call molecular rebar. So we have over 10 customers in qualification trials. One actually is launching product as we speak. So we can actually go out and buy these kinds of batteries. And incidentally, we put this in lead batteries. We'll sell about $6 million worth in lead batteries where we extend a lifetime. Another example, if you turn the slide, is tires. Everybody knows about tires. And where we were working with Goodyear on is mining tires. And these tires are 4 meters tall. So you can imagine how big they are. And the big issue there is how can you resist getting cut and chipped so you have a flat tire at the bottom of a mine. Tremendous cost for the tire, but even more because your mine is down. And what we did here, these materials have been optimized for 50 years. And in the blue, the spider diagram, this is a balanced property. And if you try to get an improvement in one, you always lose something in another. And if you notice the green, which is these materials added with just 1.5% of our material, you dramatically improve cut and chip. And that's really interesting to obviously mining tires or mining, oil, parts, tires, and so on. And so we actually have commercial sales in blowout preventers. The next target we're going to do is change how you do tires for electric vehicles. And we basically can expand this some more and have improved cut and chip, improved fuel economy, lower weight, higher toughness. And we're aiming that for electric vehicles who have a much more difficult design criteria than the current tires. And you can see in the as made, there's chunks in there. And then the discrete, you can see those little tubes, and it's the whole secret is the individual tubes dispersed. Next slide.
30-second warning.
So we have a huge range of applications, as you can see, that we're working on. In the next slide. For example, here's coatings. Coatings that last 3 times longer. Next slide. And one that's kind of an outlier, we can do chemotherapy with no side effects. And a long way we got here, but you can see the utility tubes is very broad. Next slide. So where we're at is we've begun sales. We need investment to build capacity, to add development people. We're really moving out of the research phase. We also need to keep our portfolio of over 100 patents continuing to expand. So we protect our competitive advantage is we have utility patents to protect all the composition of matter that we have for this. And with that, we'd again like to thank you for the time. We are starting to try to start work with the military, and we too have an AFWERX project. We're trying to focus in on tires because pilots told us they need better tires. Thanks. Any questions?
So Kurt, I noticed most of those depictions I saw there, the fibers, the nanotubes are more or less kind of randomly oriented. Are you able to orient them all to do sort of anisotropic stuff, or is it pretty much all isotropic?
We can orient them. For the applications we've chosen to work on, isn't needed. Right. But if you talk to my partner, he'd get all excited because he loves to do it. What you can do is you can put them through dyes and orient them that way. You can orient them magnetically. We just need an application to do that. The applications are infinite. Our issue is stay focused. And so we pick those four. That's a good question.
Right. Thanks for that.
Any others?
If there are no further questions, that was Kurt Swager. Reminder, a recent AFWERX Phase 1 winner, also looking to advance that within the Air Force. With that concludes our first session. So we're gonna jump right into the second session. Just a quick overview of the panelists. So we've been blessed with a great group of panelists for the first session. Please stay on for the future sessions as well. For the second session, we're going to be really focusing in on AI and machine learning and big data technologies. We have, first and foremost, Sarah Pearson from Defense Innovation Unit. Wesco Distribution, we have Rose Chen. Staying on is Soda Yoshi from Mitsubishi Heavy Industries. Alan Yu from Space Capital. Kenny Visig from a little company called Google. Dana is staying also from the US Air Force. Tim Crane, Army Futures Command. From AeroVironment, Derek Gores. From PropelX, Swati Chaturvedi. David's going to stay on with us also from Proto Ventures. Sarfraz Nawaz from Johnson Johnson joining in. Jacob Hahn staying with us from Deloitte. Radhika Malik from Samsung's Catalyst Fund. Destry Gorgat from Army Futures Command. And Joshua Davis-Gort continuing from United States Space Force. Thank you. Starting with our AI machine learning and big data companies. We have Laticu, Spiro Devices, Verifix, Data Shapes, Advanced Remote Sensing, and our first international participant of the night, Cognata. Kicking off the processions, we have Cognata. So we're joined by Shai Ruthman, Director of Business Development of Cognata.
Hi, Shai.
Hi.
Do you want to share it? Yes. Do you want to share it in the end, or am I going to share it for you?
If you can enable, perfect.
Awesome.
Okay, so my name is Shai Ruthman. I'm a Director of Business Development at Cognata. Cognata is an autonomous and ADAS simulation platform for autonomous vehicles. And in the past few months, we have been working on our off-road military robotic solution, and I'm happy to share it with you. Please feel free to ask questions, whatever you need, even now or in the next 5 minutes. Let's jump in. So Cognata is a 5-year-old startup company located in Israel. We're about 50 employees. Backed by investors from many different countries. So far, we've raised $23 million. And we've been working with most of the tier ones and OEMs in the private sectors for the past few years. So why do we exist? Autonomous vehicles, ADAS systems suffer all from one big problem. It's very hard to train AI systems using real data. It's hard to apprehend. It's hard to annotate, and eventually it requires a lot of work in order to take an AI system, test it, validate it, and then certify it. Naturally, if we look at this graph, we're talking about autonomous systems coming all the way from L1 till L5, where L1 is just relatively simple safety features such as the front camera or lane keep assist, and L4 and L5 are full autonomous vehicles. We know that just to validate an L2, which is a safety system such as a Mobileye camera, require around 1 million driven miles, and that's a huge effort. And then when moving to L4 and L5, we're talking about billions of miles which are required, and those are huge numbers. And we believe that those numbers can be mitigated significantly by using simulation platforms such as ours. So lately we have also started to work with military robotic application, and we're offering our off-road robotics application and also some new innovation regarding some airborne systems. And I will share it in a second. So what are the challenges in military robotics? Naturally, training autonomous platforms on digital twins and rare assets are very hard. Some of the assets that you would like to identify are very hard to photo and replicate, and those can be done easily using a simulation. It's very hard to create realistic sensor models and, of course, uncommon sensors. And then we're talking about the scalability that we have solved using cloud platform. How do we do that magic, so to speak? So we're dividing our technology into 4 different layers. We're creating a digital twin of the required area that you would like to practice on. It can be a desert, it can be a forest, any different country. We're using satellite images and all kinds of other assets, and then we replicate it and create it in our virtual world. On the dynamic phase, we're adding behavior models to make the simulation as realistic as possible. And then we are modeling the customer sensors. It can be cameras, radar, LiDAR, thermal. We have a very special method of doing that. Since it's a very short presentation, I won't deep dive into that. But later on, if you'd like to hear more, feel free to ask. And last but not least, we are doing a very massive amount of analysis and data generation in the cloud. Simulating a lot of miles is very, very heavy in terms of GPUs and storage. And we're taking the advantage of cloud platform, can be a private cloud, can be a public cloud, in order to do that. So eventually we're providing a platform which is a web-based UI that you can basically drag and drop and recreate many different scenarios and sessions. We enable the customers to work on their own maps, upload their own assets, or use our very, very large assets library. And naturally, we also offer modules for safety and regulations in order to make sure that the off-road vehicles and solutions are safe. So a little bit about our off-road simulation. It's important to understand everything that you see here are just screenshots taken directly from a simulation platform.
30-second warning.
Okay, so I will run really, really fast. So in terms, we are solving both perception, what you see, and prediction, how do you drive. We enable you to drive in many different terrains. We enable you to practice on many, many different angles, heights, and so on, identify whether you can drive or not. And I will quickly go into the movie that I would like you to see. So this is a 40-second movie. Hopefully you can give me a few more seconds. This is basically our simulation platform live in live action. You can define whatever you would like in those aspects, whether you would like to test whether you can identify perception, or just you are capable of running over those obstacles. You can check your vehicle dynamics. You can do those things in the night. You can change different sensors. You see your cameras, but everything can be done with LiDARs, with thermal, and so on and so forth. And of course, you can also do it from a flight perspective. So use cases for our simulation. It can be used for annotation, for fast machine learning. It can be used to train autonomous vehicle stacks, and it can be used for validation and safety. Thank you very much.
Thank you. Thank you so much. Opening up the floor for
Happy to
questions.
take questions.
Yeah, Shahai, this is Derek Gorch, Director of Business Development for AI and ML programs at AeroVironment. Are you, thank you for your presentation, it was very interesting. Are you looking to raise or build awareness? Because I think your tech is something that might be interested to us as we train our algorithms, our computer vision algorithms for autonomy and perception.
So currently we are not looking to raise money. We're definitely looking for partners, for customers, for awareness, and we'll be happy to talk later on.
Great, I already emailed you, thank you.
Thank you so much.
Just a quick question. I'm Sarah from Defense Innovation Unit. How many users do you have on the platform today?
You're talking about customers, naturally.
Yep. How many customers?
So from the military side, we have one customer that we have done all the development with. It's naturally a local customer. From the commercial side, we have above 10 large customers, including large OEMs, tier ones, and we are building our portfolio.
Perfect. Thank you.
Thank you.
Have you done any work with the U.S. government or military or anything like that, please? Did I miss that? I think I mentioned that or something in the middle.
Can you please?
Oh, sorry. Yeah. Have you done any work with the U.S. government or U.S. military?
So not yet. We've just started this effort, and hopefully soon we can start.
So just a quick use case question. Would it suffice to say that you're capable of taking a sensor feed and assessing the usability of a specific pathway for, like, say, an all-terrain vehicle or a Humvee or any sort of light armored vehicle through an ISR feed, or is that an applicable use case for you?
So yes and no. So we are capable of creating the entire scenario and simulation around that, but eventually, once the customer would approach us, we will connect his AI brain into our simulation. So eventually the assessment will be done by him, and we will provide all the inputs needed to do the assessment.
Thank you.
Thank you.
Moving right along, we have Paul, Adrian, and Jade Kirian, also Ryan Emmon, I believe also Charlie Mitchell, all from Latico. Excited to hear what you are developing.
Hi, everyone. Thanks for having us. Latico is inventing the future of secure content transfer, combined with workflow automation that heightens efficiency at scale in massive organizations. Today, Latico is an established video workflow company used by some of the world's largest enterprise media corporations to move high-quality video from inhospitable locations around the globe to secure broadcast facilities in major cities.
Our customers often follow your troops to places like Afghanistan and Iraq. They are journalists covering the news. They transfer video from the same environments where the military operates over what is often that slim to no bandwidth provided by cellular, local Wi-Fi, or sat phones. Latico Automation shoots that video from the public internet through secure DMZs onto corporate networks where Latico delivers the media in the precise format required by the recipient's technology. This Latico workflow is all about speed, quality, security, and efficiency. We believe this mission-critical workflow used by enterprise broadcasters could become a mission-critical solution for another large beyond enterprise producer, of visual and big data files?
That would be the US government. The agencies within the Department of Defense are required to analyze and respond to an overwhelming amount of incoming visual data in real or near real time. The better the quality and immediacy of the video, the better and more accurate the response. Video is also continually used to train personnel. Collecting and delivering video into classrooms, computers, or AR environments is a challenge today. And finally, the military, through the Stars and Stripes and other internal communications efforts, has the exact same video transfer needs as Latitude's current customer base.
Latitude meets many military needs with its current solution. This can immediately be put into a proof of concept where Latitude can add whatever custom integrations are required. The current solution can also be provided entirely from Tier 1 government certified secret infrastructure used for classified materials.
Latitude Manifest is an assignment system for notifying and updating teams to desired content, but Manifest also performs machine learning on all incoming content to sort and prioritize it in front of relevant team users, even if that content has not been previously flagged by a human as critical.
And finally, a revolutionary transfer protocol called Generative will soon replace the transfer methodologies used today by Latitude and, we believe, just about everyone else. Generative is in the final stages of development after a decade of work. Generative uses whatever bandwidth is available between sender and receiver to deliver the highest quality possible in real time, while after the fact delivering full quality. It is great for in-the-moment decision-making, perfect for after-the-moment analysis.
Latitude was founded by two broadcast veterans, Paul Adrian and myself. Paul was a major market investigative reporter. I was an international correspondent. We both spent 20 years in the industry before founding Latitude. Our chief technology officer, Joe Palaio, is a former officer with the Navy who had secret clearance when active. Richard Metzler is our video PhD who developed Generative after listening to the needs of the people in our industry. Latitude Sales Vice President Charlie Mitchell has sold complicated video solutions to enterprise customers for decades, including the White Sands Missile Range.
Latitude is a software as a service company that has been profitable for 4 years, makes several $1 million in annual recurring revenue, and is growing fast. 59% ARR growth 2020 over 2019, 158% net revenue retention. Most of our growth comes from existing customers doubling down, and only 1% revenue churn.
We're currently used by some of the biggest broadcasters in the world. The Nexstar Media Group is the largest station group in America today. That one corporation uses Latitude at its stations in 112 different US TV markets.
The trade association IABM represents more than 500 broadcast and entertainment technology vendors around the world. It chose Latitude as its Company of the Year in 2020, its highest award. It also nominated Jade Kurian as Technology Leader of the Year. The industry publication TV News Check honored Jade as a futurist in its Women in Technology Awards. Our integration partners also speak volumes about our ability to serve our market with a scalable and secure service.
Latitude won the first round of AFWorks, thank you, allowing us to transfer our technology with a financial subsidy from the government to a participating division of the Air Force. We're seeking that partner now to sign an MOU with us to enter a proof of concept arrangement to set up this mission critical video solution and bring the efficiencies broadcasters see now to the Air Force. We're also interested in opportunities with other agencies within the Department of Defense, as well as other US government agencies. Thank you for your time.
Is it okay to question?
Absolutely.
First comment. Can compete with people with media background in presentation. Awesome. I mean, one of the best presentations I've seen. I've seen 1,000, but thank you so much. So you guys, it's a compliment, by the way. Okay. So are you guys looking for funding or just looking for a project with the government? I'm just curious. I represent one of the investors. That's why.
So we're not actively looking for funding in an equity sense. We are definitely looking for non-dilutive grants from the government through its various processes to expedite the development of and commercialization of Generative.
And yeah, you guys are interested in working with the overseas foreign government, in other words, foreign entities. Are you allowed to do that, or I'm not sure? I guess it doesn't matter, right? You guys not that. I mean, I know you received some grant from U.S. military, so I don't know, it tie you down some aspect of it, but what's the
So we do have clients overseas, obviously. You know, we have Euronews, which is in Europe, and we are trying to appeal to other clients in both South and Latin America, as well as Asia. So yeah, obviously we will sell overseas. And then depending on what happens with AFWorks, of course, we'll follow those rules as well.
Okay, great, thank you. Hopefully we can connect later, thank you.
Very good, thank you.
That's good.
Okay, if there are no further questions, thank you so much, Latico team. We're going to go on to the next presentation by Verifix. John Fuez is CEO and founder of Verifix. Take it away, John.
Hey, thank you very much. Okay. So Verifix is an actionable consumer and political insights company. Next slide, please. So the team. We've recently updated it. It's myself, John Fuez, 25 years as an intellectual property attorney, top IP strategy person, former board of director of a public company. We brought on Jennifer Watkins to head up tech. She is former Los Alamos and is a published author on the use of prediction markets for aggregate collective intelligence. We also have Adam Hesch, former Navy, former Facebook, and Defense Digital Service. Next slide, please. So we are in the global markets research industry, which is a $73 billion industry. The US roughly represents 54% of that. Next slide, please. So what are we? Current research tools really limit the available insights, right, and their effectiveness. It's a streetlight fallacy. Current research looks where it can, not where it needs to be. So you're talking about things like surveys, focus groups, facial recognition, customer experience, social listening. If you're using any of those tools, it's time to stop. I have something better, faster, and less expensive for you. Next slide, please. We enable existing data, right? We discover the unknown unknowns. We do that with 4 products: our nudge lists, dynamic demographic analysis, our industry emotion index, and our implicit delta testing. We answer the what, who, when, and by how much. Next slide, please. So where is our technology from? It was born out of the hunt for Russian propaganda. We went left of bang by 4 to 5 months. This is technology that is faster than the Russian SVR system that's used by the GRU. It is currently available for use by DoD. The commercial version is essentially a dumbed down version. Next slide, please. So how does this all work? How do we discover the unknowns to amplify? So we start with a new source of data. We're not social listening. We're not surveys. We have a patent pending system that's only available to Verifix and its clients. We use an ethical data source. We use paid, anonymous, consenting data. We can do it with small 100-person panels, even with 1% response rates. We can operate in small locations of 10,000 people or more. It's a closed loop system that is also not public. Next slide, please. With that data, what can we do? Our first product, the what. What will trigger people to buy my product or vote for my candidate? Next slide. That is the nudge lists. These are the issues that, if amplified, move your customer base. These are tested issues. We know they work. They come out automatically from the software. This is not consulting. You may have heard Qualtrics, SCL, Palantir, some of the other entities trying to tell you that they can find out what will move people, and they do with months of consulting. We do it weekly with software. Next slide, please. We answer the who. What is the demographic for the easiest attainable new market share? Next slide, please. So this is our dynamic demographic analysis. We call it the DDA. It's equivalent to a Cambridge target audience analysis. We can identify, using some additional screener data, the demographic profile of the group that's sitting right outside your issue. The group that, if moved, will make a difference, whether it's with new market share or it's convincing the population to adopt your line of thinking. Next slide, please. We answer the when. This is a great one. Is now a good time to launch a campaign? Do I spend money on ads? Do I send my product out? Next slide, please. So this is our weekly industry emotion index. It's a set of 10 questions that we track weekly. The data is available weekly that shows you how people are feeling about an industry issue. With it, you can then time your actions accordingly. Next slide, please. Then we also answer the by how much. What impact will issue X have on a consumer's emotional reaction to my product? Next slide, please. That is our implicit delta testing. 99% of what you currently see in terms of AI is correlation. It is not causation. This is the first time we are moving to issue, emotion, causation, which we can test, quantify, and repeat. When we repeat our testing twice, we know we have positive issue, emotion, causation. We know what issue will move a population and by how much. Next slide, please. It's really additive data. It's always on. It's always available. We collect data weekly. The data can be used for product development. It's currently being used by another startup to help optimize and show efficacy of their product. We feed into strategy and creative on the ad side. That's where it's hot right now because of Apple's move on privacy, as well as Google's move to get rid of personal targeted ads, as well as the new EU regulations on AI. It also can be used for active management of your ad space. Next slide, please. So the data gets delivered either by dashboard or report or directly into your system through an API. It can be implemented automatically. No human is actually needed. This is essentially your behavioral science team in a box. Next slide, please.
30-second warning.
Our products, we have subscription-based, bespoke, and our enterprise SaaS. We've been mainly using bespoke to date. Subscription is what we are just coming out with. We'll be introducing in 3 weeks. Next slide, please. SaaS efficiency, it is purely software. We basically turn a profit at $5,000 per subscription. Our cost to collect data is roughly $3,400 a month. Next slide, please. People love us. Next slide, please. We have traction. We started with Nike as our first client. We've worked for Starcom, James Hardy, as well as the Air Force. We've been revenue positive since day one. Next slide, please. Next slide, please. So our ask, we're looking for a 2-part raise. We're looking for a $500,000 safe to help with the subscription launch and a test that we're doing with a major social media company to prove efficacy of the product on their platform. Following 5 subscriptions, we'll be looking for a phase 2 of the raise. We're also, in terms of DoD partners, looking for additional engagements with Solic. And that is it. Thank you.
Wonderful. Thank you, John. Any questions for John from Verifix?
John, can you get your data from large public sources, or do you need someone to provide the data for you? In other words, I'm curious where the data comes from, where you do the sentiment analysis from. In other words, there's a lot of big data out there. Where's the source?
The source is that front-end collection tool. We have to collect the data. The data, when it's collected by us, we can then process it. So it's traditional, big data, social listening, et cetera. The data that's available, the error rates are too high to do the type of calculations and predictive things that we're doing. So it's self-collected data. The glory is that it's quicker and faster and a lower, it's less effort to do. So a survey, if you wanted to do a survey inside DoD and you're sending it out to everyone, you're talking about thousands and thousands of people, we can do that same work basically by just bugging 100 people. So it's a much lower, lighter lift. Based on how we get that data, we can then do more things with it. So we own the collection, we own the method, and we own the data, which we then can repurpose on the commercial side for other uses.
Cool, thanks.
So is it the data collection? It's a manual effort?
No, it's all software. So what happened? The 100-person panel will receive 10 questions, which they will have to enter a forecast and a text entry every week on the same day for 4 consecutive weeks. From that data, we're able then to do our calculations and provide those products. Each one of those 100-person panel members are paid. That's our major expense. So that $3,400 you saw, that's our data cost. That's because we're paying people for that data. Inside the military, if we're running it in an HR application, there is no cost.
Okay, thank you so much, John. Moving on to our next, second to last company for AI, machine learning, big data. With advanced remote sensing. I didn't see David yet, so if David's not here, we'll skip him and come back to him. Is David here? So if David's not here, John Myers from Data Shapes. Oh, David, I think David is here. Hi, David.
Hello.
So we're joined by David Groeneveld, President of Advanced Remote Sensing.
Are you ready for me to present right now?
Please.
Oh, okay, great. Thank you very much. Again, I'm David Groeneveld, and I'd like to present for your consideration simplified method for atmospheric correction, which we call SMAC. And this is something we've developed through NSF SBIR. My company is named Advanced Remote Sensing, Inc., RC for short. And I've titled this presentation, Helping the Warfighter See the Threat. I'm aiming this at the Department of Defense, but anybody that has a keen interest in this area, I would encourage to give me a call or contact me so we could start a dialogue. Next. Slide. Can I control the slide? Okay, there we go. So state of the art is relatively poor. That's the reason that we went into this to begin with. And this is a Sentinel-2 image. I am not running Sentinel-2 down, but definitely their correction method, like all the other existing methods, is relatively poor. This took 20 minutes of runtime, and you can see problems across the image, including image stripes, thin clouds, haze, and smoke plume. Pardon me, slide. I'll get it down. Great. So this is an uncorrected top of atmosphere image, and you can see those same patterns across the image. Slide. This is corrected to surface reflectance using SMAC version 1. That's our software. This took 2 minutes for the correction, and it's there's one area where there's still a smoke plume remnant down in the corner. That's where you have something that's thick enough, like the small clouds that you see, that you can't see a ground signal. So how do we do this? Slide. First step is to map the structure of atmospheric effects. And as you see on the left, this is an atmospheric index grayscale. Bright pixels are those that require a lot of correction. The dark pixels require very little. And next step, we use this atmospheric index to reverse the effects, pixel by pixel, to deliver surface reflectance. Slide. We compared SMAC with the existing methods, and in all of the functional categories I could imagine, we come out ahead. SMAC is a new paradigm. It's simple, readily applicable technology. And when we add AI to enhance capability, and it'll reduce run times and possibly to sub-minute. And this is for 100 million pixel images. So we're right now for commercialization, there's a perception that there's good enough in the limited capability out there. We need to overcome that. And in order to do that, we have to be better. And our method is not yet mature. Slide. So our software now is in a version 1. It's an alpha version, and it's good, but it's going to be a lot better when we're finished with it. We're undergoing testing and enhancement, and we're using it for our own applications and not commercially releasing it yet. So our next step, and hopefully with DoD support, with interest, we will complete the method. And the main thing is to design and build a calibration target. This is a big ticket item that is holding us back. Once that's built, we can calibrate any satellite in 1 to several overpasses. The software to calibrate and QA/QC hundreds of satellites on the fly is then possible. And if we can take AI to simplify and enhance the workflow, and the software possibly can even reside in the satellites if desired. A beta version is possible as well in 13 minutes or 13 months, and we can begin the integration for DoD use then in a 2-year and $2 million program. Next. Our current traction, well, we have very good traction in cooperative projects that are in planning and in proposal stage. These are basically on my part to keep the lights on and the computers running. My preference is to get DoD support so we can complete the method and then benefit DoD programs. For example, application to existing and planned DoD reconnaissance. For example, the DARPA Blackjack program for global monitoring. And with our unique methods, combining those with geospatial neural network methods, this would give us the ability to make things just tremendously simpler. We want to add functionality, for example, correcting over water vapor correction for near infrared and shortwave infrared, which most people don't even know can be corrected or need to be. And then there's also possible spin-offs. Slide. So why work with us? Through our NSF SBIR, we've developed a superior atmosphere correction method that is faster, currently 1/10 the processing time, more accurate, and correcting over 3 times the atmospheric effects. We did this in 1/10 the time and for about 100th the budget of existing methods. Our technology will advance DoD recon. Next. So I'll take you through some images right now. This is the last images I'll show you. It's a color infrared view of Minnesota under heavy Canadian wildfire smoke. Slide. Note the box, that's the heaviest smoke cover in the image. No part of this image can be corrected using existing methods. Next. Next. The before one, the one before that, please. Great. Okay, next slide. Okay, imagine time critical threat assessment under heavy clouds or dust or smoke. We can correct all 3, and I'll draw your attention to the arrows in the lower left-hand corner. Those are boats on a lake and the pattern of the clouds that are there. This is not magic. Next. This is technology. We can correct over water. We've done it before, but it's not robust yet. And that's part of a next gen capability that we want to go after. Thank you for listening. I'd be happy to take your questions.
This is great technology. Some of the use cases that you showed, have you reached out also to NASA or NOAA? Potential customers?
Say that again about NASA and NOAA.
Yeah, those are the use cases you showed. You mentioned Landsat, so I was just mentioning that NASA and NOAA could also take advantage of your technology.
Yeah, thank you. And this is really amazing with our technology. The whole concept is if we have a calibration target, we have a series of, think of them as family of curves. So you get a single overpass, we can project right into the family of curves that then allows us to correct for all levels of atmospheric effect. And if that is the case, it's hypothetical at this point because we don't have the calibration target, but I believe we have actually really have some strong evidence that it'll work. And if that is true, then we can correct hyperspectral, and that is an amazing. That's essentially next gen, and now we can correct for 4-band CubeSats.
Hey, this is Dana Jensen. I'm with the Air Force's Office of Commercial and Economic Analysis. I noticed when you had the slide that said inputs, that the other methodologies all used multi-band inputs, but yours used something called seam statistics. I mean, without getting into the math of all this, I mean, I have a little background in this stuff.
Sure, great.
Could you explain what that difference is?
Yeah, exactly. One of the problems with the existing methods is they use radiometry. And for example, you can't use radiometry unless you understand what the sensor is actually seeing. So you have to launch a 1-ton satellite or a 1/2 ton, whatever, to be able to have the onboard equipment, lights and calibration equipment to be able to do that calibration work. That's like Landsat, Sentinel, Maxar, those kind of satellites. Well, with CubeSats, you have to save space and weight. So you can't have that aboard. We use reflectance. We go right to reflectance, and everything that we have has been generated through the study of reflectance. I wanted to show you today, there's just not enough time to do it, the method that we have to correct this, but it is very simple and very elegant. And that's how we can do this thing so quickly. We don't need to do iterations. And once we have AI added to it, this will allow us to be able to, if you can see an image, you can say, yeah, I would correct it up here this way, or I correct it over there that way. That's why we need the kind of neural network approach, spatial neural network, and which is just in its infancy, but it'd be great to apply it.
Thanks.
Great, thank you.
Any last questions for David before we move on?
Say again?
Just checking if we have any final questions for David. If not, move on to our next presentation. Thank you so much, David, from Advanced Remote Sensing.
Thank you,
now we're
Josh.
joined. Pleasure. Now we're joined by John Myers, CEO of DataShapes.
All right, so I got the floor, right? You can hear me okay?
Sounds great.
Okay, so I'm John Myers. I'm a longtime Silicon Valley entrepreneur. I've had several successful exits. I'm the founder and CEO of DataShapes, and we address the biggest problem in enterprise big data today, which is unstructured data. Next slide, please. Unstructured data can't be used directly in computers. Over half of all unstructured data is sensor data. Our unique AI/ML technology was invented to unleash unstructured data by making it computer readable in real time. We're launching an entire new growth segment within the $100 billion big data business by introducing sensor embedded intelligent ETRL, what we call ETRL, for extract, transform, reduce, and load software. Next slide, please. So war is always dependent on signals. You war fighters out there know that. Our war fighters are more dependent on sensor data than ever before. And the problem is that their computers can't consume sensor data directly. There's no universal or effective solution today to this problem. And the result is an unacceptable risk of lives and national security, in our opinion. Next slide, please. So sensor data shouldn't actually be called data at all. It's pre-data. Calling it data has led to serious misunderstandings of the problem. To use sensor data in computers, it has to be transformed, regardless of the application, to computer readable data first. Not only is there no universal transformation solution like there is for traditional data today in ETL, but common solution models that propose throwing hardware at this problem miss a critical point. Sensor data is simply too fat, it's too fast, and the valuable bits are too dispersed for transformation to be performed efficiently anywhere but on the sensor itself, and ideally as soon as the sensor is created. Next slide, Josh. So we're introducing a breakthrough solution, which is software embeddable on any sensor device anywhere that automatically transforms sensor data to a real-time companion stream of computer readable data. We call the software DataShaper. DataShaper's first job, regardless of the application, is to transform sensor data to computer readable data. Computer readable data can either be output for analytics in the cloud, what have you, or utilized by DataShaper on the device to perform an inference job, or both. Next slide, please. So we use a novel, proven, enabling form of AI/ML that we call direct learning. Direct learning is fundamentally different than the AI/ML you're familiar with. It's geometric, and it was invented to structure sensor data and to learn and perform inference directly on devices with no cloud and no hardware beyond the sensor processor. The advantages of direct learning include 10 to the 5th level reduction in compute and memory, as well as data reduction that is also in the range of 10 to the 5th. You can download a demo called Whosis, WHOZIS, on the App Store, and that'll give you a sense for how this works. Next slide, please. So we're an early stage company, and we're commercializing a unique market-ready technology. So it's a bit of an unusual situation. Usually early stage companies are still working on their technology. Ours is complete, it's patented and so forth. We're seeing clear needs and increasingly strong interests for big data and large-scale inference applications. And we have some good visibility to commercial revenue, but we're still early. We have early traction in several major markets, from big data to big defense, and we were just awarded a SBIR contract for AFWERX in ETR, data ETRL. Next slide, please. So we're building a SaaS platform through which we'll deliver application and data services. We'll also deliver an open, free, automated application builder that systems integrators can use to build applications for their clients. Right now, we work with brand name enterprises to build bespoke POCs, proofs of concept, that will translate to solutions for commercial markets. Next slide, please.
30-second warning.
Yep. So we have mature and defensible technology. Our 9 patents are broad, covering direct learning, many of its unique attributes. And we have years of know-how in using this platform. Next slide, please. We have a team of very experienced entrepreneurs. I have a unique history of creativity and IP development in several different classes. I've also founded 2 big data companies in the past. Next slide, please. And this is one hell of a great team that I have with world-class AI advisors and so forth. Final slide, please. So I'd like to ask you to think about 2 things. First, we are going to bring in some outside capital. Right now, the company's funded by myself and one of my co-founders. And second, we're interested in working with any of the enterprises represented out there on this call to develop solutions for either big data, ETRL solutions, or for inference applications, provided they're of large commercial significance. That's the end of my presentation. Thank you.
Thank you, John. Opening up the floor for questions for John Myers from DataShade.
Looks like I stumped you all.
Well, actually, I want to ask a question here, if you don't mind. You have a great technology, actual potential. I know. Have you thought about the actual application use of it in civilian sector in actual ordinary market?
Yeah, there's so many because enterprise today gets less than 0.5% of enterprise sensor data ever reaches an analytics platform. Think about that. So one use case that we're working on today with a confidential automotive company is essentially grabbing all their data off the 100 or so sensors on their platforms and reducing it by about 10 to the 5th, which creates an executable essentially paradigm where they can pull the information off. It's got to be asynchronous, and so they need to pull the information off when they have connectivity. And right now, there's just far too much data being created on these platforms to facilitate that. So if we can drop 30 gigabytes an hour, which is what an F-150 produces, to a couple of megabytes, which is what we can do, then we facilitate that, make it possible for that company to have a virtual real-time view of their entire platform and how it's running throughout the country. So that's one use case, but there are many, many, many use cases.
Right. Yeah. That's all. You have a lot of potential there. So I can actually think of a few in my head right now. But anyway, yeah, maybe we can talk later. Thank you.
I'd love to talk. Thanks.
Okay. If there are any more questions for John, go ahead and ask away.
Yeah, I'm not surprised. I just told you had a problem that you didn't know you had, which is getting data off of sensors. And I just presented a solution that you haven't heard about, which is a new form of AI that that addresses the problem, but you're unfamiliar with. So, you know, it's common to kind of get this pause and silence when I speak.
I
Hey,
think
John.
Wesco wanted to ask for this.
Yeah, hi, John. This is Rose. I represent Wesco, and we are a global supply chain and distribution company. We do handle a lot of sensor data. I think this is great. I wanted to learn more about it. You did mention about using graph and reduce the data. How is it compared to some of the graph AI?
You know what? I have to admit to you, I haven't gone to school on graph AI. That in fact, they've never come up, which is remarkable actually, and I'm going to have to study it. So, you know, why don't we get in touch, and you know, I'll give you my take on it. But you know, either they're infringing on us or they really can't do what we do. So I'll have to figure out what they do, and I can respond. Send me an email. I'll give you a response.
Sounds good. Thank you.
Okay, thank you, John from Data Shapes. That concludes our AI, machine learning, and big data panel. Moving right along, we're moving a few minutes out of schedule. We're starting our third and final session, which is a focus on cyber. So just take a quick look at today's panelists. Of course, the panelists from all the previous sessions are welcome and encouraged to stay on and to chime in and give your feedback to the companies. We're joined by Capital Factory's Helena Krusek, by Thales, Sol Cates, Desri Grogan from Army Futures Command, Sodi Yoshi from Mitsubishi Heavy Industries, Tim Crane from Army Futures Command, from Misako Group Hanko, from Deloitte, Jacob Hahn, and Jim Root from the Dana Foundation. Pitching companies today, we have Q-Secure, Westlight AI, Arch Nimbus, Resilience, and Miner Eye. We'll get started right away. First up is Arch Nimbus's David Moon. Is David here?
Hey, Josh, there was a change of the schedule. Resilient X is going to go first.
Perfect. Wonderful. So we have from Resilient X, Andrew Carter, president and co-founder.
Awesome. You guys hear me?
Perfect.
All right. Well, thank you all for being here today. As you said, my name is Andrew Carter, and I'm the president and CTO of Resilience. At Resilience, we're providing a safety assurance as a digital infrastructure layer for complex distributed system of systems. Slide. I was the architect of the Army's ground-based detect and avoid system, which was certified back in 2016 for routine beyond visual line of sight applications for remote drone pilots, which no commercial system has achieved to date. In 2012, we had the system working. We had it integrated, everything working together. We brought it to the FAA for approval. And they looked at the system and said, well, it looks like you guys solved the technical problem, but how do you know it's all working together? At the time, we thought we had a great answer. We told them, well, we tested the crap out of this thing. And if you've been involved in aviation at all, you probably see what comes next. They told us, well, that's how you know it was working yesterday, but how do you know it's working right now? And we really didn't have a great answer for that. And then they started asking us a bunch of questions like, well, what happens when that sensor goes down and this latency spikes and this single board computer overheats? And we really didn't have great answers for that either. So we ended up spending the next 3.5 years developing and certifying safety assurance capabilities into the system, such as health and integrity monitoring and graceful degradation. We formed Resilience at the start of 2019 to answer these tough questions. And I've been fortunate enough to hire much of my former team to form the nucleus of Resilience. Slide. In 14 months since developing our initial capability, we've been funded to the tune of $1.5 million from the FAA, NASA, the Navy, the Ohio Federal Research Network, and the Air Force Agility Prime Initiative. We've recently been selected for the prestigious Starburst Accelerator program, which will begin this summer. We're deployed in 3 locations, or kicking off an additional 10 pilot program deployments in the next 12 months. Slide. But our vision's really grown to exceed the initial UAS traffic management vertical, which we were targeting. autonomous cars, drone delivery, autonomous delivery rovers, urban air mobility, or flying cars. These autonomous solutions have been termed collectively the Internet of Moving Things. And these system of systems are often relying on data from each other to make safety critical decisions. But how do you know if the data is good, bad, latent, or if the system sending subsystem is working correctly or is even the right system at all? Garbage in, garbage out. Computers can only make decisions based on the information they're given. If they have bad information, they're going to make bad decisions. In our experience designing these systems for the DoD and FAA over the last 14 years, there are two questions which are always very hard to answer in these distributed, federated environments. That's how can you tell everything is working correctly? And what do you do when something goes wrong? Answering these questions provides the safety assurance that these industries need to scale. Slide. Because each of these verticals or elements of the Internet of Moving Things currently exist in some testbed, trial, or data gathering capacity, but nothing has been deployed to scale at anywhere in the world. In order to scale, these industries need an additional layer of pervasive safety known as safety assurance. An example of a smart cities environment is assisted with visuals here from our friends at the Autonomy Institute. They are blanketing cities in the infrastructure needed for smart mobility, shown here on the left. These technologies can be dual purposed for ground and flying applications. But what happens when a car crashes into one of these smart infrastructure nodes? Do the Teslas need to start spacing themselves out further due to reduced navigation performance or higher latency? Do the drones drone deliveries that are flying overhead need to reroute around some area because they may no longer have surveillance in some airspace and a helicopter could be taking off over some building? Slide. Resilience provides the in-time, system-wide safety assurance needed to answer these questions and keep these complex ecosystems from grinding to a halt in the face of adverse situations. In-time system-wide safety assurance is a term we've co-opted from NASA. It's built on three pillars of monitoring, assessment, and mitigation. With monitoring, we horizontally integrate across the ecosystem to monitor the health and integrity of the various components and systems. We detect something's gone wrong, we assess the impacts. Impacts may affect some set of operations or operators, or maybe more geographically constrained, or maybe a time constraint. It's only happening for the next 5 minutes. And finally, we orchestrate an ecosystem-wide response to mitigate and reduce the impact as much as possible. Slide. Our software framework is adaptable to different environments using our runtime configurable rules engine to provide this in-time system-wide safety assurance. It provides a dashboard for real-time situational awareness shown here for the system administrator or maintainer. We integrate everything from networks, switches, radars, weather sensors, machinery, cloud-based software, and other IoT devices. We keep the systems up and running through the real-world issues which will occur. Slide. Many systems exist today to perform fault management, health and integrity monitoring, safety assurance. Every commercial airplane we fly on has these systems, or else we'd never step on board. But these systems are very tightly coupled and are built around these known systems with defined bounds that are under control of a single system architect. Yesterday's systems can't keep up with the federated IoT-like environments that system of systems are moving towards today, such as with smart cities and autonomous mobility. Slide. Filling the safety assurance gap in order to scale is a top R&D priority for many of these Internet of Moving Things that we've been fortunate enough to take advantage of. These industries represent a $6.6 billion addressable opportunity for our niche alone in the next 5 years. They involve complex system of systems where uptime, reliability, or safety are vital to success, and ensuring these elements are critical for needed. Slide. We're currently riding a wave of opportunity that's only going to grow. There's no path to scalability that doesn't contain safety assurance of these complex safety critical ecosystems. We're looking to leverage the Deep Tech Network in 3 key ways. We're currently raising a $2 million seed round of funding and are eager to speak with deep tech investors. We have 2 phase 1 Agility Prime STTRs and are looking for DoD contacts to help us navigate the MOU process for both of these programs, as well as direct to phase 2 opportunities in the future. And finally, we're looking for customers, strategic partners, and channel partners that are interested in our technology and want to build a relationship. Slide. Thank you for your time, and I'd love to take any questions.
Can I ask a quick question here? How is your situation with the intellectual property security? I mean, how is secured those?
So right now we treat most everything as a trade secret. We haven't filed any patents. We're currently developing a few algorithms that which we believe will be patented. Actually, one of them through one of the SDTRs that we have. So the way we built our platform is it's a really a framework for plugins. So we're not planning on patenting the actual framework. The individual plugins that do something unique or novel would be the patentable IP.
Okay. And then you plan to produce everything in USA, right?
Yeah, everything's.
Yeah. Oh, okay. Right. Just want to make sure because when you do a trade secret, yeah. No, that's fine. Thank you.
Any other questions for Carter?
If nobody else has one, I got another one for him.
Go for it.
So Carter, what is the plan with the 2 million you're looking for? I know you mentioned something about build out tech team, and development stuff. Is that mostly you're trying to do, or?
Yeah, so right now we're right about the start of our go-to-market. So we're deployed in 3 locations. We're starting pilot programs across the US. And the technology is essentially mature enough now to begin to find the customers, get it integrated, get it running. And so part of that 2 million is going to be to continue down the roadmap. We focused primarily on the, of the monitoring, assessment, and mitigation. We're primarily on the monitoring step. We want to move as we collect data towards the impact assessment and mitigation side of things. We do have that in the drone space that we're kind of experts in, but want to move into autonomous vehicles and industrial Internet of Things as well.
Thank you.
Andrew, what's your pricing model? Is it by units, or how do you plan to structure it?
Yeah, so our business model, we kind of have 2 main business models. Right now, we're running as software as a service. Our pricing model around that really scales with complexity of the system. So right now, we attribute system complexity to really the number of components or systems that we're monitoring. We plan to, in the future, add a data element to that. Obviously, some sensors require a lot more data processing to monitor than something that's over like a lower end network. So we're also building towards more of a MATLAB type model. If you're familiar with MATLAB,
yep.
Where it's particularly for DoD applications, selling into the large primes. We want to be able to package our software as our software core, and then the tooling around it that enables somebody to configure our software, put in their own plugins that have access to their own proprietary data to solve their problem, to enable fault tolerance, graceful degradation, fault mitigation within their complex system of systems, which we may not be the subject matter experts in.
Thank you.
All right, thank you very much, Carter. From Resilience, next up is Westlight AI. Aaron, you hear us okay?
I can. I just joined. I see my slides here. Is it time to go?
Yeah, we're running about 5 minutes early, so you're welcome to jump right into it.
All right. Great. Thanks for your time today. I'm Aaron Greenblatt, founder of Westlight AI. At Westlight AI, we build trust. Facts matter, and we ensure the integrity of those facts. Next slide, please. So let's start with an example, the Big Dig in Boston. It was one of the most complicated highway projects in history, moving an entire highway underneath a historic city, digging within 5 feet of active subway tunnels. Any project this complicated carries risks. Next slide, please. Here on the left, that's a car. It's underneath concrete tiles that fell from the ceiling, 26 tons of concrete. The cause? Use of the wrong glue. Now, any construction project has lots of details that matter, lots of facts that need to be right. Even worse, these facts change all the time due to never-ending change orders and design revisions. Next slide, please. The government faces similar information sharing challenges. Prior to 9/11, the intelligence community had information about a pending attack, but no one connected the dots across different agencies. This is still a problem. The US's national security depends on the ability to share the right information with the right people at the right time. Next slide, please. At Westlight AI, we've developed information assurance technology to solve this problem. We manage critical data in complex and often secretive or contentious environments. Our initial target markets include commercial construction and government. We have multiple pilots in the pipeline, and we're backed by Blackhorn Ventures, a construction-focused venture capitalist. We're also supported by Phase 1 and Phase 2 SBIR grants with the US Air Force. Our technology combines end-to-end file data tracing and AI analytics with intrinsic security. The system is not platform-based and works even if information leaves traditional corporate network boundaries. Our system is ideal for working with contractors or sharing information between government agencies. Next slide, please. Before I tell you how our technology works, let me introduce the team. My background is in machine learning with a PhD from Stanford and experience in data processing and computing. Our CTO, Adrian Llanes, ran the design engineering team at Nokia. He led the first version of many new projects, their first multi-million user cloud install, first embedded satellite system, and first Windows tablet. Adrian has a decade of experience in engineering execution. Calvin Kam is our construction expert. He introduced 3D building models to the construction industry. He currently advises 15 governments and many commercial clients on construction policy and deeply understands the commercial market needs for information assurance. Craig Schultz from MIT is our resident cybersecurity expert with experience from Lawrence Livermore National Labs. Karen Pieper, with a PhD from Stanford in computer science, specializes in high reliability systems and pioneered techniques still used in ASIC design today. Mike Lyons is the co-creator of Stanford's Technology Ventures program, has been in entrepreneurship for 30 years, and has held positions at 5 venture funds. His startup created the airport body scanner, and Mike holds a top secret clearance. Mary Korn brings operational expertise, having been a serial COO and CFO everywhere from startups to publicly traded companies. Next slide, please. Now, our technology. I'm sure you're all familiar with full disk encryption, where data is encrypted and there's a key, or a small number of keys, that unlocks the whole disk. We also encrypt data, but each file gets its own key. You then log into your system and it appears as if all your data is there. However, in reality, everything is still encrypted. At the split second you open a file, we forward your request and lots of associated metadata, the name of the process being used to open the file, system time zone, hardware IDs, system language, and so on, to a remote decision engine. On the decision engine, we run algorithms that trigger actions. In a security use case, it's similar to credit card fraud detection. We're looking for unauthorized file activity, and then we can remotely delete the file as necessary. For information awareness, we can notify stakeholders on certain events, including when someone is sent a file but then ignores it. There are many other use cases for our technology, but in the interest of time, I'd like to open up the floor to Q&A. Happy to discuss deployment scenarios, the commercial market, or any other questions that you may have. Thanks for your time today.
Thank you, Aaron. Opening up the floor, questions and answers. Okay. Any questions for Aaron, Westlight AI? Okay. If we have no questions, we'll move on to the next one. Thank you so much, Aaron. Aaron Greenblatt from Westlight AI. Aaron, maybe put your information in the chat so people can reach out to you as well. Okay?
All right. Thank you.
All right. Moving along. Next up is Arx Nimbus. David Moon, CEO of Arx Nimbus.
Thank you, Josh. And thanks everyone for attending today. Very interesting sessions. We're here to talk about cybersecurity risk management, a $7.3 billion industry segment. Next slide. We have a problem. I know you've heard from several cybersecurity solutions developers and companies today, but we have losses in cybersecurity despite all the sophistication of the solutions of the type that you've been hearing about and many more in the commercial space. We have losses today of 700 billion and growing rapidly, growing faster than our ability to stem these losses. For the last 20 years, we as a society have applied very sophisticated methods, some of the most sophisticated technology known to man in cybersecurity protections, and yet it's simply not enough. Today, we're spending 170 billion on cybersecurity solutions, and we're not gaining ground. Why is this? And every company that you know of, every company that you may be invested in as an investor is subject to this set of conditions. And that is, we lack a GPS to provide guidance on our cybersecurity strategies, our solutions, what we can expect from them, aligning cybersecurity with the business, and being able to make business-led decisions that are data-driven around the proper cybersecurity protections that a given enterprise really can benefit from most. Today's world of cybersecurity is very reactive. It is not forward-looking. It is based on a break-fix model that says, I have a vulnerability, it's been identified, let's go fix it. We're continuously playing catch-up on this learning curve, finding things, fixing them, finding more things, fixing them. Today's CISO commonly refers to their role as that of whack-a-mole, simply reacting. We have many compliance gaps as a result of this. The process is very costly, and most corporate leadership today in most organizations, public and private, will tell you that we know we're spending a lot on cybersecurity, we just don't know where it's going or what it's actually doing for us. So we use metrics, and those metrics are financial in nature. Most cybersecurity programs do not have insurance grade results and cannot plan their own insurance programs appropriately. Most cybersecurity programs cannot participate in ESG efforts on the part of the enterprise because they simply don't have the governance insights and transparency necessary to accomplish that. And all of these programs today are highly opinion driven, relying on professional opinion and expert judgment, which when they get into a courtroom, as inevitably happens post-breach, is an absolute weakness for the enterprise in terms of opposing counsel. And court records and court results document this very liberally. We also tend to be threat blind in today's cybersecurity programs, and they tend to be very technology driven without real transparency and insight on the part of the board or senior management. Next slide. What is the solution? How would we solve this issue if we're going to solve it? Well, we would need data. We would absolutely need data. But what kind of data? It's not extremely more complex than if you think about your own automobile insurance. What kind of data would we need in order to determine automotive risk? We need to know the type of vehicle. We need to know how many miles a year it's actually driven. And we need to know something about the neighborhood, the demographics, other conditions. This is the data that we as a society use to determine risks of all shapes. We are applying a cybersecurity focused effort using actuarial science of the type used throughout the insurance industry since the 1600s to determine cybersecurity risk exposure, and the costs associated with those risks so we can properly underwrite them. Probability has to therefore replace likelihood in our model. over 90% of enterprise today uses a discounting of cybersecurity risk based on a concept called likelihood. Likelihood is not a mathematical construct. Likelihood cannot be multiplied, divided, treated mathematically in an expression. It's simply a concept, very soft concept. We would need a solution that was business driven and not technology driven so that the business can actually understand cause and effect in terms of, we took a cybersecurity strategy, we gained a certain result. If we take the next cybersecurity strategy, what result can we expect? And the way that business determines results is through dollars and cents. Arx Nimbus today, our Thravaca technology, is the only technology in the market that expresses these results in financial terms so that the business can understand and participate, and so that we can treat cybersecurity risk the same way we treat every other risk in the enterprise: credit risk, counterparty risk, supply chain risk, etc. And we would need validated data as well. We talked about that. We have loss data that goes back to 1998 on specific losses in specific conditions. We cover all 28,000 NAICS codes with an industry-tailored approach, and we operate on 48,000 risk expressions, which are pairs of threats and vulnerabilities. A risk in cybersecurity gets triggered when a threat matches up with a relevant vulnerability. So we have to have this detailed level of mapping those interactions, and it has to be specific to the individual enterprise. Today, regulators are requiring this approach of objective, data-driven risk management, everything from SEC to GDPR in Recital 76, New York Department of Financial Services, Health and Human Services, SEC, OCC, US Treasury, et cetera. You can go right on down the list. So this is a very exciting opportunity for companies to really get themselves better and be able to track in basically Six Sigma terms their progress as they go down the path of reducing risks. Next slide. We have a significant amount of traction with financial services companies, banks, healthcare providers. The partner community is growing rapidly, among which we're in a now 2-year agreement with Tech Data, the $36 billion technology distributor. And we have repeat customers, and we're getting very, very good results with the customer base. Next slide. Next slide. So we, sorry, previous one. Sorry, I said it twice. I probably got out ahead of you. Okay. We've been issued a US patent and now an international patent. We started the technology, our first implementation was with US Strategic Command in a project sponsored by Mark Roth, participating with KBR, MITRE Corp, and the Applied Physics Lab at Johns Hopkins. We operate with a 72-hour implementation SLA. Any of the conventional methods in this space are essentially consulting projects with a model or risk model of some type embedded inside them. Our competitive advantage is that this is a technology, it is, because it is not based on professional opinion and expert judgment, we base almost all of our results on scanned data, and we can implement within 72 hours. We have a global agreement with Crowe, the 8th largest accounting firm in the world, for validating controls. So we can get down to a very detailed level of controls. We use a threat source that operates on an AI engine that covers threat emergence in 23 native languages and is able to determine advanced threat trends that apply to the specific enterprise. And again, we're the only available solution that characterizes risks in financial terms and shows the organization the carrying cost of individual threats, risks, vulnerabilities, and capabilities. We're 100% based on regulatory frameworks, and we adhere to the precise language that regulators themselves use and expect in order to facilitate compliance sign-off. Next slide. These are some of the metrics that we use in the product, and I would just call our attention to the fact that we started off understanding that you can't really say much that's meaningful about cybersecurity risk unless you can measure the natural state risk that the enterprise would throw off if there were no controls and no protections in place. Once having established that, one can now subtract the risk reduction effects of individual solutions and strategies from that total. But you simply have to start there. We're the only solution in the marketplace today that is capable of doing that. That's based largely on an economic model that we developed at the University of Chicago Department of Economics. We're also able to show the enterprise which solutions bear the greatest likelihood of cost recovery so that the results of the model can be economically driven as well. And we're able to essentially do triage, which says get the low-hanging fruit first, then move on to the next things. And from that, if you look in kind of sort of near the upper right, there's the digital risk journey. Most organizations do not know where they are in terms of their advancing of their own cybersecurity risk. And we actually are able to quantitatively, in a way that's auditable and that ascribes to actuarial standards, illustrate where they actually are. Now, for the first time, management can have a conversation, and this is what's really exciting to me, about where do we need to be, how soon do we need to get there, what is it going to cost us to get there, and what's a realistic plan. They simply haven't been able to have that because, again, they're in this reactive mode. So this is a very important turning point in the world of cybersecurity risk management. Next slide.
We should wrap it up, David.
So our competitive advantages are, again, that we're completed in 4 days, our 72-hour SLA. We have financially quantified and aggregate detail risk data. We eliminate expert opinion and professional judgment, providing additional litigation preparedness. And we've got an insurance grade risk valuation model. ROI on investment, we just recently completed one earlier this week, in fact, for a 120 billion plus organization. And the ROI was 3,392%. We have complete regulatory traceability as well. Next slide. This is our roadmap. I won't go into detail here, except for the fact that we're raising 2 million currently. Next slide. In our team, we have the founder of the cybersecurity major at West Point. We have the former chief accounting officer of Sony Pictures Entertainment, who authored the $400 million charge on earnings at Sony in the wake of the North Korea breach. We have the head of systems development for Moody's Investor Services and the former transformational CIO for the state of Illinois. We also, our CFO was former divisional CFO for Lockheed Martin for their Skunk Works in Southern California, and Paula Mitchell carries a top secret clearance. We've got a senior risk advisor to the White House, and Stuart Richmond, who's our CTO, who's the former CTO of Randian, working with Dick Parsons and Sherry Redstone. Next slide. Questions?
David, maybe you address your ask for your current state of business.
Current state of the business is we spent a lot of time on engineering the last year, and we're now rounding the revenue curve at about 500,000 ARR. So we're still in a bit early stages. We're again looking to raise 2 million, and primarily that is due to the advanced point where we find ourselves in terms of engineering. Most of the use for that capital is in the marketing area.
Okay, any other additional questions for David?
Yeah, David, do you see this product? I saw on the last slide when you were talking about some of the integrations, like within ServiceNow's marketplace, and I saw Archer in the far corner. Do you see the product really supplanting what Archer can offer today? And as the converse, there's a number of different GRC products out there that purport to give that kind of information. And I'm sure you're very familiar with the slate. What's your general understanding of how, from a dashboard perspective, what you showed? I'm thinking like on that one slide you had the NIST controls, I think it was, listed out by, right? The one other question I had is at the outset of your presentation, you talked about relating business level risks as well. Do you add any more enhancement from a business language perspective in conjunction with those regular NIST controls to add more power to a CISO's ability to speak to the board and to gather support for whatever initiatives they need to reduce risk to an acceptable level, as they've talked about?
We do, and we do budget efficiency analysis for the current program as well as pro forma. We can profile M&A transactions from a business standpoint, pre and post, so that we can profile the risk of the to be acquired enterprise, as well as a weighted risk picture of the final integration post-merger. And then in terms of the overall scope, we cover IoT, shadow IT, mobile, cloud, all aspects of technology risk, so that's within the entire scope of the solution. And apologies, Jim, what was your earlier, did that cover, was there another piece?
No, you absolutely did. Thank you, David. It was kind of a disjointed thing. I've got a number of questions. I'll probably have some more for you offline.
Look forward to following up.
Yep.
All right, thanks everyone.
Thanks, David. Any other questions, you can put them in the chat. Up next is MinerEye. We're joined by Gavin Kerr. MinerEye is the second international company of the evening.
Awesome. Thank you, Josh. Hey, guys. Yeah, so I, as well as everybody else, understands the how tough of a day it is to get through a full day of slides, especially that's coming up on 5 p.m. Eastern. So I'm gonna rattle through this really quickly. Definitely hit the key points, but feel free to stop me or say, hey, go back to that if you want me to slow down a little bit. But without further ado, I'm here to talk about a technology called MinerEye. And the problem it solves is that data is really difficult to manage and really difficult to govern. And on this next slide, especially when talking about unstructured data, which is growing really fast, and the fact that we all want to move to the cloud to become more collaborative, we want to protect our data, we really need to think smarter and at scale about how we're going to do that, because as data continues to grow, it's becoming more and more difficult to handle, and not only handle, but as we want to leverage it as a strategic asset, we really want to look back on if we're taking all the steps to do that the right way, especially as humans. And so on this next slide is a real 10,000-foot view of some of MinerEye's use cases and problems it can solve. And we're going to touch on a few of those in this presentation. But more importantly, on this next slide, we're going to walk through a little bit on how it does it. And so MinerEye is a combination of byte-level pattern recognition and the unsupervised clustering of those patterns. And what that means, it's a really fancy way to say it's able to work across different file types in all different kinds of file locations. So in this slide, you can see it's comparing a Word document to a PDF, CAD drawings, and things like that. And it really provides the ability to look at a granular level at actually what's inside of a file, what's inside of the information. And it classifies information based on context. Again, meaning what's actually inside of the file, not just the metadata. And so this next slide, we're going to go into the first use case to maybe provide a little bit more understanding on what MinerEye can do, starting with secure collaboration. The ability to share the right information with the right people at the right time is really important, especially in the DoD space. And so MinerEye, being a tool that can dynamically classify this information, really adds to the efficiencies of information sharing as well as security. because if your information is underclassified, then someone who needs to see it isn't going to see that. Overclassified, excuse me. If it's overclassified, then it's going to prevent people from seeing it. And if it's underclassified, then it's a security risk, and there's important information in there that needs to be secured in a better way based on the subject of the information in the file. And so if you're looking at something, a federated network like a US BICES or a Centrix-K, and you're looking to share information with your coalition forces, the ability to make sure that information is automatically tagged and categorized based on predetermined notions, based on whatever environment information you want to set up, it really ensures that the people who need to see that information can see it. And so you're not stymied by human error based on either overclassifying or underclassifying information. And on this next slide, a separate use case is forensic data analysis or data security. The ability to find specific information, whether that's names of people, project names, bases, anything like that. A project we worked on with AFRL, the Air Force Research Labs, they actually gave us pre-redacted documents, documents that were blacked out by hand. And MinerEye came out and popped up with 6 or 7 instances of PII that people actually missed. And so the kind of message I'm going to hit home on is we all understand that humans can't deal with the scale of data, especially as it gets bigger and bigger. So utilizing a tool like MinerEye can really help us stay ahead of that curve as data continues to be added into the ecosystem. And so MinerEye can also help with things like CMMC, a very hot button issue right now around the DoD and in the industry space, as well as something like insider threat scenario. If someone wants to take information, they're not just gonna save the file as the same name and try to email it out that way. They're gonna take certain steps to try to circumvent the security protocols in place to help them from taking that information. It could be something like financial information on an Excel spreadsheet that somebody copy and pastes into a notepad, then sends it out via email. And because MinerEye is actually able to work with, again, the context of the actual information inside the files, you can set up certain parameters that flags whenever specific secure information leaves certain places in your environment. So you can say, hey, this happened, let's maybe look into it. Maybe somebody just did something by accident and saved something in a different file share. Everybody does that all the time. Or maybe there's actually a scenario we need to look into deeper here. And having that ability to look in there and make that decision is something that MinerEye can bring. And on the next slide, the last but not least use case is the cloud. And so as we continue to move in the cloud, there's certain security and cost concerns that we keep running into. And the recent move from cloud first to now cloud smart underlines that we need to maybe go back and take a look at if what we're doing is really effective, because the old model of taking everything and dumping it into the cloud and then dealing with it later has resulted in huge bills as well as huge security risks. So MinerEye is going to provide 2 benefits there. One being the ability to look at all of your information and make sure you're only bringing over to the cloud what you need to, meaning you're identifying duplicates, you're making sure that the information you actually want to move to the cloud is going to the cloud and nothing more and nothing less, as well as the security ramifications with that, being that if you want to move something to the cloud, you want to make sure it's secured in the proper way first so it doesn't get lost when it's up there. And on that touch point, there's been a big push within the DoD to move historical scan documents into historical paper documents, scan them and then work with them digitally. MinerEye is really good at that. The ability to work with this digitized information and pick out certain topics, help categorize things, tag it, create that governance or that auto taxonomy of information. That's going to be really important for these DoD customers moving forward. And so next slide, please. Yeah, so with that being said, there's some more slides in here about the install, and I know there's 1-2 slides down about the actual environment. So I'm very open to questions. And like I said, I know I breezed through that. So if there's anything you guys want to go back to, I'm more than happy to do that.
Perfect. Thank you, Gavin. Opening up the floor for questions for MinerEye. Okay, I think people have reached the end of their attention span, so we'll move right on to this one. Thank you so much, Gavin. Last presentation of the night. Do we have Q-Secure here?
Yes, I am definitely here, and I'm ready to put some more people to sleep again.
I don't think quantum attacks puts anybody to sleep. If we're talking quantum attacks, maybe people will wake up,
Well, yeah, I mean, quantum is a really nice trigger word for people, so maybe it will help someone get someone's interest. So let me share my screen real quickly, and away we'll go. So can you all see my presentation? Yeah. Okay. Sounds good. So yes, we are in the working in the quantum space, and our focus is scalable cryptography for the post-quantum enterprise. We are a dual-use technology for government and the enterprise, and right now my presentation refuses to change. So let's see if we can get to the next slide. Perfect. So we, all of the founding team, we're all Silicon Valley execs. We've all had exits of our own, and we've brought on a team of true experts. So our head of engineering is used to work in the intelligence community, building out some of the core infrastructure, including satellites. The former CTO of the U.S. Air Force, Frank Konechny, joined us recently as an advisor. So I had Louis Gasparini, who was the first CTO at RSA to take them from an unknown entity to a multi-tens of millions of users. And of course, packet optical platforms from Juniper. Domenico is here to help us, and one of the best cryptographers in the world in post-quantum cryptography joined our team recently to help us build our solutions. But what I want to talk about right now is why we're even touching cryptography, and why is there a need in the industry for this? So cryptography is something we use to protect data everywhere. I mean, that goes without saying. Most of us here are security folks. So what's happening right now, both at the nation state level and individual attacker level, is that they are siphoning data out of corporations in bulk. I believe that China has something like 20% of all the data generated, and they're using it to process it. Now, what makes it interesting is that with the advent of quantum computers, you actually do get speed ups in being able to brute force cryptography. So the data that we've encrypted and data that's supposed to have a 25, 50, or 75-year life cycle, depending on where you are in the industry, can actually be broken very, very soon. Now, NIST has recognized, and what makes quantum computers so powerful at this is the fact that they don't calculate the same way as classical computers do. In a classical computer, a byte is a 1 or a 0. It's very binary. And when you look at a 24-bit, 64-bit instruction set, that's a single instruction set that gets processed linearly. So for us to calculate it out, you actually have to add more CPUs that can parallel process and get data. Quantum computers, in a quantum computer, a qubit can actually be 1 or a 0 or any number of states in between. And through the process of entanglement, it can actually be both at the same time, which leads it to be able to calculate very large numbers very, very quickly. The way you scale a quantum computer is when you scale a classical computer, what you do is to double the power, you double the CPU. In a quantum computer, you just add one more qubit because it's a nonlinear progression. So as the qubit counts grow, the ability to brute force cryptography only increases, and it increases exponentially. So what does it mean for our cryptography that we use every day? So symmetric cryptography is how we encrypt data. Data itself. So that's your AES algorithms. That's what we call military grade, AES-256. And you take it, you encrypt data. You can do it as flat files, full disk encryption, homomorphic encryption for data in use scenarios, and all of these things. Now, Grover's algorithm, when run on quantum machines, actually simplifies AES cryptography by half. And of course, it opens it up also to cryptanalysis techniques, which is figuring out how you generated the random number. The random numbers we use right now are not random enough. So it does open it up to significant risk from brute force attacks. Asymmetric cryptography, on the other hand, that's your famous RSA and ECC algorithms. They get reduced to nothing. And we use them, and we use asymmetric cryptography for sending symmetric keys, for transferring that data and those keys across. And it becomes a very large problem set for us in the industry. So that's what we decided to focus on. So we're looking at ubiquity of use, data at rest and in transit. We're adding intelligent cryptographic orchestration to take cryptography to where it has never been before, because all of our cryptography, the way it's been used in the market, has really been hard-coded in, essentially. I mean, that's the easiest way to explain it. When we create a VPN tunnel, we use the same Diffie-Hellman, we use the same IKE key exchange, and we use exactly the same algorithms. We can reestablish the session and clear the keys, but we can't change algorithms. We can't bring true cryptographic agility in there. We can only do it at the session connect-reconnect level, which is when vulnerabilities start occurring in VPN concentrators. And that's only one of the thousands of examples of how we use cryptography today. Everything we build is around standardization and compliance. So all of the algorithms we use for post-quantum resilience are NIST approved. You're going to see them in the FIPS 140-3 revision. We're actually getting waivers to be able to use NIST 140-3 because we are using those algorithms and we're in compliance. And we're built to military standards. We're actually being vetted by the Space Forces team for pen testing, and we're coming up on standards compliance through our documentation, which is built to MilSpec 498 and a bunch of other things. So we are being standardized on within the government sector. So what we do is we ensure that all of the devices can communicate and still be quantum resilient, which incidentally is also classical technique resilient as well, when you look at it. And we can go to any devices through our use of secure architecture. We can actually provide reference architecture when we partner with our clients, and we look at both data at rest and data in transit, how we protect it with strong dynamic encryption, and we bypass a lot of the vulnerabilities that are inherent both in TLS and certification authority-based systems. So, and that simplification of steps actually allows us to be faster and more resilient, as well as offer better protection. And by faster, we've actually clocked our communication protocols at double the speed of TLS 1.2 or TLS 1.2 hybrid. For data at rest solutions, we can either do—
Hey, Costa, 30-second warning, okay?
Absolutely. So for data at rest, we can either do all of the data full disk encryption ourselves, or we can power other products for tokenization and data loss prevention and other things to protect data irrespective of the use case of that data. And of course, we can do satellites. We're in talks with government entities on that right now. Our sales pipeline and revenue projections are around the federal business, where we already have really good relationships with Raytheon and SAIC as prime contractors to take us into our existing builds. We're working with the Air Force quite heavily and about to engage in another phase 2. Through their direct programs, and we have customers in the banking, telecom, and data and cloud sectors. Our raise roadmap is that because we've all of our founders have had exits, including myself, we've essentially self-funded up until the beginning of this year. We raised $500,000 in January. Or I should say late December, early January. We're raising another $250 right now, and by June we're going to go for a much larger raise at 4 on 25, to be able to continue to scale and build out our offering. So, having said all that, I'm happy to answer any questions that you may have, if I haven't put you all to sleep yet.
Thank you so much, Konstantin. Any questions for Q-Secure and Konstantin Vilk? Like we said at the end of the day, from Thales, they've requested that you reach out to Saul Cates, just so you know. He had to sign off. Any other questions for Q-Secure? Thank you so much. That wraps up in all the pitch events. Thank you for all of you who trudged on through with us and made it all the way to the end. Quick recap of who we heard from today and sitting on the panels. Our panelists, starting out the general session, we had a wide range of panelists from government, strongly from the DoD, but also major corporations and investors. Moving on, the companies that we heard from today. We heard from in the first batch, OptiPulse, Elementum 3D, Trax-NA, Molecular Rebar Design, Aquavio, and B612. In the second session, my mistake before I said that Swati Chaturvedi was on the AAML session. She was actually joined us with the cyber session. But for this, we had interesting mix from DIU all the way down to Deloitte, Johnson & Johnson, and Proto Ventures. And the companies we heard from was Lattico, Spiro Devices, Verifex, DataShapes, Advanced Remote Sensing, and of course Cognata. And all the way to the end, our cyber expert panel. And we had 5 pitching companies, ending with Q-Secure, who we just heard from. And also joined by Arcs, Nimbus, Westlight AI, Resilience, MinderEye, and as I mentioned, Q-Secure. Any final thoughts or questions that we have from the panelists as we went through the companies? If so, please put it in. We're going to leave up the chat for just a few more minutes so people can continue to interact. Thank you everybody for joining us, and we're looking forward to the next showcase, Industry 4.0 on May 20th.